5th Research Conclave on Day 3 of International Summit for Packaging Industry 2025. The last 2 days were absolutely enriching and eventful. We had a plethora of insightful discussions and lectures from numerous international and national speakers from industry, from research institutions, from academia. And today, we are bringing you another eventful and interesting series of lectures from highly knowledgeable and distinguished speakers, followed by oral and poster presentations. To start with the day, I would like to invite on stage our special guest of honor, Madam Dr. C. Tara Satyavati, Director, Indian Institute of Millet Research, Hyderabad. Thank you, ma'am. I would also like to call upon our special guest, Professor J.P. Sharma, former Vice Chancellor, SQUAST, Jammu. And may I humbly request Shri R.K. Mishra, sir, Director, IIP, and Professor Tanveer Alam to please come up on the dais and take their chair. So without any further ado, I humbly request Professor Tanveer Alam to kindly set the tone for the event.
Thank you, Dr. Astha. Very good morning. Dr. C. Tara Satyavati, special guest of today, Shri R.K. Mishra, sir, Director, IIP, Professor J.P. Sharma, ex-Vice Chancellor, SQUAST, Jammu, other dignitaries of the dais, delegates, research scholars, colleagues, and dear friends. Once again, on behalf of Indian Institute of Packaging and my personal behalf, I welcome you all for the third concurrent event of ISPI 2025. It is indeed a great pleasure and honor to welcome you all in this august gathering. As all you know, that for last 2 days, we have organized technical sessions, business sessions, networking dinner, and first version of ISPI 2015, we have organized Packathon 2025. And I'm happy to share we got overwhelming response, especially Packathon. This was the first event we have organized under the banner of International Summit. As the theme, 5S, this year ISPI theme, I recall almost 6 years before when we have organized earlier version of ISPI with the theme of 3S packaging, that was safe, secure, and sustainability. But today's arena, the smart and interactive packaging is so much important for today's, for tracking and traceability, and of course, intelligent interactive with the customer and packaging. We have included 4S is smart packaging. And more important is that we have to have harmonized packaging, standardized packaging. Keeping in mind this aspect, we have included 5S. So now we are, with the theme of 5S, this summit we are organizing. But more important is that the IIP for the years is very much associated and worked for last 60 years. We have closely working with the industry. Now under the leadership of President Director Sri R.K. Mishra sir, his focus on research and education program at IIP. Therefore, now we are more focusing on research activity in association with the industry. So now third important concurrent event, here we are, inaugural function is the Research Conclave. With this word, I once again wholeheartedly welcome you all for this inaugural program of Research Conclave. Thank you very much. Jai Hind, Jai Bharat.
Thank you so much, sir, for setting the tone of the event. May I humbly request Sri R.K. Mishra, sir, and Professor Tanveer Alam to felicitate our guests with a bouquet. Dr. C. Tara Satyapati, Director, IIMR, Hyderabad. May I have a great round of applause, everybody. Professor J.P. Sharma, sir, former Vice Chancellor, SQUASC, Jammu. Sir, may I request Sri R.K. Mishra, sir, to please address the august audience.
Good morning, ladies and gentlemen. The dais is loaded by academicians. I am the only exception. The director of Millet Research Institute, ex-VC Jammu University, Dr. Alam, the convener of the whole ISPI 2025. When this idea was mooted that we will hold this summit and we'll have 3 concurrent events, it put an issue of how useful that those 3 events would be. But I'm very happy to notice that so far the last 2 days have produced a lot of stimulating discussions, and the feedback, I'm a non-packaging person, but for 2 years and 3 months have pushed some packaging into my mind also. So I can see that a lot of things have been spoken about, a lot of issues have been raised, and answers have been given to questions. The feedback from the APF and WPO representatives has been that the conference has exceeded the expectation. It has been a very high quality exchange of ideas and dissemination of thought process. This research conclave is aimed at giving an opportunity to the young minds to listen to the experienced and educated people in the field. And I am very happy that the IITs of the country is coordinating and responding to the needs of IIP, a lesser known Indian institute. When I joined as director in 2022 November, I said that we have 2 words common with IIT, that is I and I. The third P has to move towards T standards so that we become a force to reckon with. That is my intense desire that we should move in that direction. And for that purpose, I am thankful to the Government of India that it has sanctioned a huge amount of capital expenditure of 106 crores, which will result in establishment of a world-class packaging laboratory. The ambition is embedded in the words itself. This laboratory, which is coming up in Mumbai, the headquarters of IIP, will be ready in 2026. Our Diamond Jubilee year. For those who do not know, IIP was established between packaging industry and the Government of India in 1966 with only one center in Mumbai, and it has now expanded to all corners of the country with 8 centers. We are increasing our outreach, we are increasing our educational courses. Dr. Alam has taken intense efforts in IIP Delhi to start a first ever undergraduate course, that is BS in Bachelor of Science in Packaging Technology from 2024 session, for which a lot of investment has been made in IIP Delhi. We are focused on serving the interests of the marginalized and the small farmers and the MSME in a very sincere manner. So I have just given a brief of what my vision is for IIP going forward. We are going to increase the manpower, human resources available in IIP. On this occasion, I must greet everybody on the International Women's Day, the ladies especially, gentlemen also, because we work together. I express the hope that the topics that have been selected, including nanotechnology and e-commerce oriented things, and sustainable material, what can be developed. These are areas which are of immense importance to our country. The focus of a consumer on the sustainable part of the consumption is very intense, especially the educated consumer now is aware of the environmental damage which cannot be repaired or undone in the coming times. We are already hitting that 1.5 degree from the industrial area, that temperature barrier. And packaging should not become a punching bag for anybody. So it is in the interest of the packaging industry, and especially the people who are concerned with the research and development of materials of different technologies, that we rise to the occasion and we deliberate upon ideas which can tell the human population that packaging will not be a roadblock in the road to sustainable development. That is a sustainable development goal as well of the UN. And all of us, if we deliver on the promises that we are making to ourselves. In the last Research Conclave and Asian Packaging Congress, when I was very young as a director, 2 months old, in January 2023, I had expressed the hope that we will move towards developing new materials. On a parallel platform, Kuraray of Japan is extolling virtues of the materials which have been developed by them. Now the ball is squarely on the court of the Indian academicians and the research scientists and developers to develop something which is more cost effective, more attuned to the needs of the Indian situation and conditions, and create something which we can go to the world stage and talk about. I also represent IIP in World Packaging Organization and Asian Packaging, APF. There, if our scientists deliver something good, the stature of India and the utility of all our commitments, it increases. So the topics have been well chosen. I would hope that, and I'm sure that a document which emerges out of these deliberations will be of a high quality, and the question answer which is there after the end of the presentation will also have substance in it. I'm very sanguine that this will be a very meaningful exercise, and the final day will not be a day without special achievements for all of us. It is the third day of the conclave. Officers of IIP, especially of IIP Delhi, have worked very hard, but this is the most important day for this event, where the future developments will be deliberated upon. I'm being very hopeful, and I'm sure that you will do the best. You will join minds, and the joint intellect delivers a better result than a single individual intellect. This is what the current theme of scientific achievements is. You would be seeing that the Nobel Prizes are being shared very frequently nowadays on the same topic. There is nothing that stops us from aspiring high and delivering on it. Thank you. Jai Hind.
Thank you so much, sir, for a motivational talk. It is an honor for me to introduce our special guest, Professor Dr. J.P. Sharma, who is the former VC Squast Jammu. Sir has a vast experience of over 30 years conducting strategic research, guiding and teaching PG students, conducting national international training programs, and carrying out agricultural extension activities in the farmers' field. May I please request you, sir, to address the gathering in a few words.
R.K. Mishra Sahab, my colleague for a long time in IRI, Dr. Tara Satyavati ji, Dr. Tanveer, and dear participants, I also take liberty to congratulate you all on this International Women's Day. And I also congratulate the organizers for organizing this wonderful program, which has been very close to me during last 40 years of my service. I spent around 34 years, sir, in IRI, Pusa Institute. Then Vice Chancellors of Jammu Agriculture University and also Agriculture University of Kashmir, Srinagar. All this time I felt two important things, sir, in agriculture. And when we say agriculture, it is not a sector. It is 50% of economy. When we say that share of agriculture in GDP is 17%, 20%, it is not correct. In that case, we are taking the value of all the raw product produced. And when we take into consideration the value-added products, whatever you find here in the hall and outside the hall, mostly things are coming from agriculture. In that case, the contribution of agriculture in Indian economy is around 46%. So it is not a sector. And the importance of the agriculture sector, that during everything, but agriculture maintained 3.4%, 3.14% positive growth. And we could provide food to our all population during that crisis also. And when I felt when we were talking about Honorable Prime Minister's focus was doubling the income of the farmers, enhancing the income of the farmers. Then I felt and highlighted this on various platforms. The income of the farmer cannot be enhanced by production. Production is increasing at the rate of 3%, but the wastage in our country is about 20%. Last year, our production was more than 600 million tons, including food, grains, and horticulture products. And if you take into consideration 20% wastage, it was 120 million tons wastage, which is more than the production of many countries, like Australia. That much we waste. And our Honorable Prime Minister once said, zero hunger through zero wastage. Why I am talking these things? Here comes two important things in our country. Because packaging, when we talk of packaging, agriculture is the most potential area, all food items. So in my mind, the products, that income of the production system can be enhanced by processing, value addition, and marketing. And when we come to the processing, value addition, the 5 things you have mentioned very beautifully, I will say another dimension you add, sentimental value of the packaging. It is very important when you relate it to village, your pind or your cow or something like that, then we tempted to subscribe to that product. And also beside these things, yesterday I was traveling from Jammu to this place. The opening of the product, packaged product, is a small thing. Even if you travel in the aeroplane, some people are struggling to open that ketchup. And sometimes, sir, you are old person, look, let me help you to open it. A small thing. And I have noticed, sir, the value of packaging itself is more than 25 to 30% of the product. I have noticed this. In Srinagar, sir, saffron is there. When I was there in 2020, the director of agriculture of Srinagar told me, sir, the cost of the saffron 1 gram before packaging and certification of the product was 70 rupees. Once the government of India established a laboratory there for testing and beautiful packaging, that cost went to 200. That is the value. Honey, which we call organic honey, it cannot be organic honey everywhere because the honeybees can bring honey from up to 3 kilometers. And we cannot control honeybees that they will collect honey only from those plants which have been grown organically. But when you say organic honey, its value enhances many times. The rate of organic honey in Kashmir, Doda district I visited, was 200 rupees, sir. The same honey, Tara Satyavati ji, in Delhi, in your IRI, it is being sold 2,000 rupees. 200 rupees, pure honey, organic honey. It can be organic honey in Jammu and Kashmir by default. But the rate was that time 200. Here, organic honey from Jammu and Kashmir in IRI, farmers mall, it is 2,000. It is because of the labeling, branding, packaging. Considering the importance of this packaging sector, I invited Dr. Tanveer ji to our both of the universities, Agriculture University Jammu as well as Kashmir. And we signed a MOU that your institute develop our KBK's competency in this area of packaging. Because it doesn't only give the attraction, the safety of the food and also maintaining the quality and aroma, fragrance. It is important. And when I came here, sir, the IARI, Indian Agriculture Research Institute, I asked him, requested him, can you work with Indian Agriculture Research Institute, which is a premier institution in the field of agriculture. And on my request, some of the batches from IRI were deputed to his institute, and they were having very high regard the kind of activities, Dr. Tanveer, you have initiated. And in times to come, I hope this institution will come at par with IIMs and IIT. I was a student of IIT. I did my PhD from there. And I really feel, Dr. Ghosh is here. I also interacted many times with him. So I think this is a multi-institutional, multi-country participation. And after 3 days of deliberations, you will be able to develop a roadmap with these words. I congratulate each one of you. Thank you very much.
Thank you so much, sir, for motivating us. On this special day of Women's Day, International Women's Day, we celebrate the strength, resilience, and achievements of women who inspire change and shape a better future for coming generations. It is an honor for me to invite and to briefly introduce our guest of honor, ma'am, Dr. C. Tara Satyavati, who is the Director of Indian Institute of Millets Research, Hyderabad. Ma'am has been serving in the Indian Council of Agricultural Research for the past 23 years in various roles. She has research experience in millets for over 17 years. She has served as a program leader for pearl millet improvement in IARI Pusa. Let's welcome ma'am with a big round of applause. Ma'am, please.
There will be a file with this today's name. And I think 7th March is the file. So a very good morning to you all. First of all, most respected R.K. Mishra ji, Dr. J.P. Sharma ji, Dr. Tanveer Alam ji, and dignitaries of the dais, students, faculty, ladies and gentlemen. This is an opportunity to speak about what we are doing in millets and also how packaging can join hands with millets. I come from a non-packaging background. I'm from agriculture background. And you all are aware that like the latest technologies now you see in different fields, information technology, talk of AI, ML, then in other fields we talk of nanotechnology, then in others we speak of many robots and many other things. Nowadays when we are talking of food and other things, people have become concerned and are now aware that they need to eat good food, nutritious food that will not just add calories to their body, but the required essential nutrients to their body for increasing the overall performance and strength of each individual. So when you talk of such foods, millets are the ones which are packed with nutrients. And on the other hand, we also are talking of climate change, reducing water reservoirs and many other things, increasing temperatures and all. So we need crops that can come up in such harsh conditions, use less water, withstand these things, and then provide us with good nutrients and good food. Then when you look with all the crops you have, you find these millets are the ones which can withstand such harsh conditions, high temperatures, with less water, provide nutritious food to humans, animals, and to the earth for its sustainability and many other things. When we talk of millets, these are a group of small seeded cereals which can be used as food, feed, fodder, and in many forms. And there are different kinds of millets. We have millets like bajra. I think here north many people consume it, bajre ki roti. Then jawar ki roti bhi खाते हैं और many products आप खाते हैं. Ragi, जो finger millet बोलते हैं, वो भी खाते हैं काफ़ी लोग. And then we also have other millets like proso millet or chena, foxtail millet that is kangni. Then we have barnyard millet, sama. Many different kinds of millets are there. But at Indian Institute of Millet Research, we do research on 9 different kinds of millets. And when we look at the national level, in all the millets, bajra occupies nearly 45 to 50% of the total area, and it provides 55 to 60% of the total production of the millets. And then comes sorghum, it occupies about 25 to 30%, followed by ragi, that is finger millet, it occupies about 10 to 12%, and the remaining all other small millets, they occupy the remaining proportion. A number of items can be prepared from these millets. You can use them as the rice. Rice means not the dhan or paddy. Any grain which we get from the field when we again do all the primary processing and then make them, bring them in a usable form or edible form that we call as rice. Those can be used like the grain as such, the rice can be used, or it can be made into flour, atta, or rava, or suji, dalia, many things are there. But one problem with the millets is, though they are packed with nutrients, full of nutrients, when they are broken or when they are made to flour or when they are made to rava or suji, their shelf life gets reduced. I think all of you can understand what I mean by shelf life. Is there anyone who cannot follow the word or the term shelf life? The keeping quality and the quality with the aroma and other things. So, in order to, it has to come here. I am able to see here, but it is not here. So, in order to keep the freshness, the quality, the desired aspects, all of them in right amounts as we see them in the fresh material, they have to be retained in the end product we prepare. Yeah, now it is on. Yeah. So for that, we need the help of packaging. So my issue as a researcher of millets, they are packed with all the nutrients, but they have poor shelf life. So how can you people help us, or how can we together work together and give the goodness of these millets to others, the consumers? So the issues, if you see, uh, rightly the theme of this international conference is your 5S. So safety, you talk of safety, security, standards, smart and sustainable. For me, when I talk from the millet's perspective, the food I pack, the material I pack should be safe, and it should not interfere with the product integrity. That's why it should be secure, and the package should be the standard which is acceptable by everyone, and also smart to leverage the technology, and also sustainable so that it is not going to be a burden on the environment. Now, just now I mentioned we have different kinds of millets, pearl millet, jowar, finger millet and many other things, and these are all packed with nutrients. I said they are good for farmer, good for planet, they are good for you and me, and they are also good for business. So there are many options available. If you see, just now Dr. Sharma ji mentioned that agriculture along with other value addition added products contributes to nearly 40 to 46% of the GDP. But we talk of only few percent. So these millets are some unexplored item. Unlike rice, wheat, maize and other things, these are the ones which are in a big way are being accepted worldwide, not only in India, abroad, in EU, US and many other countries. There is a big demand, and only issues they see is the point of shelf life. So there is a rising demand for millets because they are powerhouse of nutrients and they are gluten free. Many of you are nowadays hearing about gluten allergy, and that is leading to IBS and many other things. And so people are looking for safer, viable options of looking for gluten-free foods. And then millets are, I said, they are providing sustainability to the environment because they require less water, they make the environment very friendly, and they don't cause any harm. Now if you look into the shelf life of millets, shelf life refers to the period during which the product, here it is a millet, it maintains its quality, nutrition value and also safety for consumption. And the shelf life of the millet varies depending on the type of the product we are making, and then the kind of processing method we are using, and also the storage conditions. So depending on the type of the product, type of processing, if you see here we have given about 8 millets: sorghum, bajra, ragi, foxtail, kodo millet, proso millet, barnyard millet, tittle millet. If you take them as grain as such, the shelf life is about 1 year. So there is no deterioration in the quality. The moment we make them into flour or dalia or rava or something else, the quality, the shelf life quality deteriorates. If you see, for grain it is 1 year. The moment we polish, we are on one hand trying to increase the nutrition and provide food security and nutrition security to the people. But on the other hand, we need to balance this thing. That is why we are looking to join hands with the packaging people. So if you see here, whole millets, they can be stored for 1 year without any problem at room temperature, and up to 2 years if they are packed with vacuum packing. And de-hulled millets, they can be stored for 3 to 6 months under dry and airtight storage conditions. And millet flour, you can store them from 7 days, that is 1 week to 2 months. And if you are keeping them in fridge or refrigerated condition, you can go for 6 months. And processed millet, it is only 2 to 12 months. So what are the factors that affect the shelf life? From the agriculture perspective, we talk of the moisture content, we talk of the temperature, we talk of the lipid oxidation, or you talk in terms of oxygen and carbon and all those things, and then the processing method, then the packaging type. So all these factors, they affect the shelf life, and all these factors can be addressed through the right kind of packing and packaging material. So if you look into the role of packaging on millets, we have these raw materials, the grains, the flour, the suji or rava, and without packaging, these products cannot be stored safely, and the shelf life is very low. So what are the different packaging material that we use in millets are generally available in the market? Just now I was listening to the latest information in packaging in the next room. There was a parallel session going on. But as of whatever is available in the market, these are the things available for us to use in millets. You have PET types, PETs, HDPE, PVC, LDPE, PP, PS, all these things, you know the advantages and disadvantages of them. Now with these limited options, we have to go for packaging of the millets. So whatever be the material I use and choose, they should be able to preserve the quality and maintain the shelf life, or in fact help us to increase the shelf life, and they should be able to protect from the external contaminants, and they should be able to help us display the marketing and information material. Then also they should be able to help us to address the environmental concern. We should not be again dumping the things and disturbing the environment. And also convenience and consumer appeal. Convenience in the terms of the pricing, and also the, just now Dr. Sharma was mentioning, opening of a, what is that, sauce or the ketchup packet. So convenience should be there, consumer appeal should be there, and also they should be fitting into the regulatory compliance. So all these things should be there, and also they should gel with our products. So if you see now, previously people used to store the grains in open or in closed structures like that. Now we have the bags, gunny bags, jute bags, plastic bags. Now people are using, the farmers are using jute bags, plastic bags. Now we have a different number of products developed in our institute under the brand Eat Right. Eat Right is the brand of Indian Institute of Millet Research products developed by us. So the kind of material we are using are polyethylene, polypropylene, polyvinyl, then ethyl vinyl alcohol, polystyrene, polyamide, and these are all the other material that we are using. And if you see the Eat Right products, you can see different kinds of packaging is same. Not every product has the same packaging. So we are also doing a little bit of research of what kind of material can be used for our products. And if you see the kind of material, suppose we have bajra puffs. These are the grains which are put under high temperature and high pressure. The outer surface of the grain is intact, and only the internal contents are cooked. So for such things, if we keep them in outside, the quality becomes lost and they become soggy. We want that freshness and crunchiness in that. So here we go for biaxially oriented polypropylene with nitrogen filling packing. Whereas we have the flakes like poha, rice flakes we have millet flakes also. There we are going laminated with nitrogen flushing. And then we have ready to eat mixes and recipes where we go for retort packaging for ready to eat. And here you know the advantages of the retort packing and the number of layers we have, and which add to the quality of the packaging material. We also have different kinds of value-added products like the grains and flours. What we are doing is vacuum packing so that the shelf life is increased for more than 6 months. And now we also have milk coming from millets. So for that, we are going for Tetra packs, or sometimes we go for glass bottles. And we do have our own machinery. We go with a vacuum packing machine, or we have this multi-headed, fully automatic packing, form, fill, and seal, that kind of machine we have. And then there should be provision, and we also use that provision for labeling information. So you can see the kind of information we provide on our packaging material and the products. And we also have, previously the FSSAI standards were present only for rice, wheat, and other things which have been exported. Now millets also have gained momentum, and these are also being exported. So FSSAI, it has come with, along with IAMR, we have come to the standards for quality control of millet grains, and they have been released by Honorable Prime Minister during 2023. And these are the grains quality control measures, or the standards for the different millets. You can see already mentioned for different millet grains. And moisture should be this much, extraneous matter should be this much. Like whatever measures and rules or standards are set for different crops. Similarly, these standards are set for millets by the collaborative effort of FSSAI and IAMR. And the previous one was for grains, and this is for now flour. So jawar ka atta, this side, this is bajre ka atta. You can see the difference. 1% difference in moisture is good for bajra, and it is not good for sorghum. So all these things matter, and for each millet the standards vary. And these are the standards for ragi ka atta and mixed millet flour. These are not available as of now in public, and only because they have been released very recently, things have to be percolated deep into the market segments. And the recent packaging systems we are using for millets and millet products, high barrier packaging, just now we were hearing to the Japanese speaking there about these things, and then active packaging, where this is one of the way to increase shelf life of the food products, to increase, maintain, or improve the conditions of the packaged food product. And there also we are trying to go for a multi-layered pouches or sachets with oxygen scavengers that will be effective in storing the dehulled grains. And if you see, a many number of startups are there in the market. We ourselves have one technology business incubator under the name NutriHub, which is supporting, incubating, and hand-holding different startups. Till date, we have supported more than 400 plus startups across the nation, and they have come up with a number of products. You can see the kind of packaging, the kind of packaging material, the kind of the product. A number of things have been displayed here. And if you look into the option of future of millets for packaging, till now we are talking of packaging material to store the millet products. Now I'm talking of the option of using millets for packaging. So this also can be another option. We can go for bioplastics, then smart packaging, and personalized packaging. So nowadays, people have come up with the concept of millet starch that can be used as a packaging material. So from millet starch, we can go for edible films and coatings. And I think 1 or 2 years back, we have seen somewhere that some person has come up with edible cups and cutlery prepared from millets. So with the millet starch, now we can think of such kind of packaging materials. So they can be used for food, pharmaceutical, and packaging industries. And millet starch-based films can be used for production of active edible coating, and these films can maintain food safety as well as extend the shelf life of the product. These are the research articles which have been quoted using the millet starch. So in the end, I would like to conclude that now everyone is talking of a sustainable packaging. So one thing, we are looking for packaging of the millets and millet products, and also on the other hand, we are also trying to explore the possibility of using millet starch for packaging. So sustainable packaging is not just a way, but a trend, a necessity for the future of the millet. By embracing innovative materials, efficient designs, and responsible practices, the industry can create packaging solutions that benefit both the consumers, environment, and also the benefit of everyone involved in that. So thank you for giving this time and your kind attention. Thank you.
Thank you so much, ma'am, for sharing your expertise and your knowledge about millets. Millets are indeed a superfood offering numerous health benefits, sustainability, and a rich culinary heritage. And we really look forward to future collaborations of IIP and IIMR Hyderabad for development of sustainable packaging solutions. With these words, we would like to felicitate our honorable guests. May I request Shri R.K. Mishra sir to felicitate our guest of honor, ma'am, Dr. C. Tara Satyavati, with a memento. Thank you. May I once again request sir to kindly felicitate our guest, Professor J.P. Sharma sir. May I request all the dignitaries on the dais to please gather for a group photograph. So please take the center stage. Sir, please join us on stage. Professor Anup Ghosh, sir. With these words, we conclude the inaugural program. I would request everybody to please rise up your seats for the national anthem.
आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
So thank you so much, all respected dignitaries, guests, esteemed speakers, for being the part of the inaugural session of the Research Conclave. In another 5 minutes, we'll be starting with the first session of the Research Conclave. Please stay here. Professor, IIT Delhi, to take his chair on the dais, please. Dr. Sumer Singh. Professor Dr. Vimal Katiyar, Dean IIT Guwahati and Chairman Scientific Panel FSSAI. May I request sir to please take his chair on the dais. Dr. Sudhanshu, Secretary APEDA, who will be joining us very shortly. And may I request Dr. Kirtiraj Gaikwad, Associate Professor, IIT Roorkee, to please take his chair on the dais. For chairing the session, may I request Professor Anindya Datta, Dean USBAS, GGS IPU. We welcome you, sir. Dr. Sumer Singh.
Good morning, everybody. The first speaker for this session is Dr. Sumer Singh, Associate Professor from IIT Delhi. Dr. Sumer Singh is an Associate Professor at the Department of Design, Indian Institute of Technology, and he specializes in product design, transportation design, design for sustainability, design sketching, computer-aided surfacing, and design innovation. He holds a PhD in environmental sustainability and design from IIT Delhi, and a MDS from industrial design, and a BTech in civil engineering from Acharya Institute. His research focuses on environmental sustainability and design, with publication addressing topics such as environmental impact assessment frameworks for product packaging and implementation of circular economy strategies in the automobile industry. In addition, Dr. Singh mentors startups, engages in sponsored and consultancy projects, serves as a curriculum review expert at Footwear Design and Development Institute, FDDI, an institute of national importance under Government of India. Dr. Singh, I invite you to start your session. It starts now, and roughly there will be 15 minutes of talk, and then maybe 5 minutes of questions.
May I please request Dr. Bindu Ranjan, Subject Faculty Associate Professor, USDI, GGS IPU, to kindly take chair on the dais. Sir, please.
Saying good morning, everyone. It is just 15 minutes to noon. So I'll try to keep it little lighter, and on the background of whatever has been discussed in the inaugural session, if I recollect, there was a push towards research and development, how we should contribute and collaborate. There was a push on how packaging can be helpful in pushing products ahead in market. So I'll try to come to these things. This is a brief background just for those youngsters. Anyone of you interested to become an academician researcher? Yeah, there are people, only few. Researcher and want to be a faculty in IIP when it becomes as equivalent to IIT as was discussed in the first session. So here is a brief outline, like we are not only teachers, our teaching role is only 25% to 30% of our job. Most of the other work goes on sponsored projects, handling government funded and other international funded projects. Then another 20 to 30% goes on PhD supervision, and then to outreach like in platforms like this. So this makes the role of a faculty little more exciting. So it is a 4 job altogether, and when when you are doing 4 job, you are actually not being accounted for anything. So you can do either of them or you can do none of them. So, so best part of it is that you are very free and you are very promoted to be dynamic in whatever way you want to. So today I am going to cover on environmental sustainability, and this session is mainly to nudge you to be excited about making a career in the domain of environmental sustainability as a researcher. I see that this is a complex structure. Have you come across this triple bottom line, people, planet and profit? So if we only talk about environmental sustainability and we talk about planet, there is no profit and there is no people in concern, it is not going to sustain. The structure itself will become very unsustainable. So in between you will have socio-environment, in between you have socio-economic and eco-efficacy kind of thing. So how intermediate interactions also happen, and how you then find a in-between path, which is the entire sustainability metrics cover, which will talk about social sustainability, economic sustainability, environmental sustainability altogether. So sustainability, when we talk in design, some of you are from students in design and back in industry, so we come across these kind of words, no? We will have to do with eco-design, somewhere you learn. So when you say eco-design, you are only talking about environment and you are not talking of sustainability. When you are saying climate change, you are only talking about heat and calamities which are happening because of climate change. Water conservation, we are only dealing with water and deforestation, design for environment. Then there is a circular economy concept. These are the upcoming concepts, like Industry 5.0 talks about how do you bring sustainability in picture in your Industry 4.0. You are RRR, this is not that movie RRR, this is reuse, recycle and reduce. And then design for sustainability, somewhere you call of green design. But when you start looking for what sustainability can really contribute, it has to take into account its economic, social and environment sustainability altogether. So with this I'll start. This is one from my Masters of Design days 20 years before. I had this concept of why do we not make sustainable materials used in different objects. Like this is a lampshade designed by jute thread. This was when I was a student, and that was the time when I started thinking about how sustainability can be. And somewhere you would be also thinking that we should do something for environment. But majorly in our life's race, we just forget about it. So this was how do you make lampshades using jute threads, and I had optimized on some processes which can speed up the making of lampshades with jute threads, and this was submitted as one of the projects. And in the project presentation I remember that I had kept 4 or 5 different lights and lampshades over there, and these were shown as concepts. So the concept was like it has wireframes inside which can be recycled, and it has jute threads on the outside which can biodegrade, which further made me to move in the area of sustainability, and I started looking for what are the things around me and how we are treating it. So I wrote a research paper on living with junks in 2006, and that time the entire industry where I was working was majorly talking about design for manufacturing and assembly, failure mode effect analysis, and how you can optimize the processes, how you can make materials reduce, cost reduce. No one was talking of sustainability as such. At that time I was very much triggered that when people are reducing the timeline, the case study of Toyota came in picture. Like Toyota has reduced the concept to market timeline to 2 years, where General Motors and all are making vehicles at 3 and 3.5 years from concept to market. So my question was that why do we need more vehicles on the road? We have enough vehicles and we don't have so much roads. And we are in the same situation. When you move in traffic in Delhi, you will find that we are in the same situation. So I was just saying that when we throw these out, discarded objects, are we creating junks, and how do we live with junks? That was the paper. Then another was like killed by plastic. So we are getting killed by plastics on day-to-day basis. We will be disposing these plastics, which goes into our food chain. Your and your animals consume these plastics. So my experience was like I was having bath in a village with a shampoo sachet used on my head, and this shampoo sachet was kept on a stone. If someone is exposed to this village kind of environment, you will have talab or pond or a well. Nearby I was having a bath, and a goat came in, and goat started chewing this shampoo sachet, and I was like literally trying to pull it out from goat's mouth. And goat was like snatching it from me, and I couldn't stop. It took this plastic, and this triggered me that what happens to this plastic when it goes inside the body. So it is consumed in some other way, and another animals consume that. Further that goes into water chain. Fishes will consume it in plants, and fishes will be consumed by humans. So some or other plastic is going inside your body. So killed by plastic was one of the papers which triggered me. So further I did my PhD in environment sustainability. So I majorly work on decision support systems, framework for mitigating how we live with environment and how we can be sustainable in the domain of environment. So these are few papers from my PhD, parameters for environmental impact assessment of product packaging. You will find this on Google Scholar, and environment impact assessment framework for product packaging. In one of the journals of, one is in the Journal of Packaging Technology and Research, which is being managed by IIP. I am thankful to IIP for that. And this further led me to do further research, and these are my research scholars. Luckily we have all three research scholars I am addressing over here. All three are over here. Harshit Jain is working on framework for sustainable assessment of materials used in primary food packaging. So we see that there is a lot of wastage, there is a lot of health hazards, there is a lot of environmental pollution, but can we solve them as a one problem itself? No, we cannot, because parameters are very different. And for that you will need to have a solution, maybe addressing to behavioral change, maybe addressing to, see, plastic as such is not a bad material, but the problem is that we are not managing the use of it, so therefore it becomes a bad material. So it is a behavioral problem, it is also related to economic problem. We could have thrown this into a proper bin, but there is a economic of scale that these kind of bins are not available. And can we call it as a environmental problem, like someone is taking it and putting it on some other use which is not mean for that kind of use. So Harshit is working on research on how we can find these parameters and make a decision support system to advise governments to give triggers to users that how we can become more sustainable with food packaging. Another research is research by Vishal. Vishal is working for a framework and a development of a biocomposites for sustainable packaging application. We can discuss Vishal's project over in detail. You can contact these people. Vishal, just raise your hand. Vishal is here. Harshit is also here. Yeah. So I have come over here with a purpose that we can collaborate and do something. So Vishal has developed a rice husk fiber reinforced starch antimicrobial biocomposite film and for active food packaging. So we can disclose this information because it is published. We have a patent on novel rice husk fiber reinforced biocomposite film for packaging, and these are two papers which are again available online. You can see these papers. Very nicely written paper and appreciated in good journals. Assessment of this is like, one is parameters proposed for sustainability assessment of biocomposite based rigid packaging, and another is a fiber based composites as alternative material for sustainable packaging and design. So what Vishal actually did is that he took agricultural waste, rice husk, and he embedded antimicrobial elements in it, and these both are natural. And further he processed it, tested it in laboratory, and then we have this material which is quite impressive, giving impressive results. So we tested it on strawberries, and you can see there are 3 different kind of strawberries over here, and there is this time lapse which shows that how these deteriorate. So you will find microbial growth in first sample, whereas second sample also has microbial growth, wherein our film has capacity that it controls the microbial growth. Yeah. So our result was quite significant, and it increased the shelf life of food, and we tried it on bread package as well. So a strawberry would be lasting for 3 more weeks, and the bread would be lasting for 4 more weeks as compared to present. So this will save the wastage of the food as well as it will save on heat release in the environment. So it will benefit on both ways. So Rahul is another PhD scholar with me, and he is working on framework for. Rahul, you are also here? Yeah, he's not here in this room, but he is one of the organizers of this event. So Rahul is working on framework for how we can use traditional ways in which leaves were used for packaging. Like if you see earlier times, palm leaves and other leaves have been in practice, and how we can use these leaves as it is with least of production application on it, so that the cost on environment is a little lower. So his work is in progress. His papers are not come yet, so I'll not be disclosing his work as such. So with this I close on the session. Hope this was interesting, and I have saved some time for question and answers if possible.
Yeah, questions please for Dr. Singh.
Okay. Thank you.
At the end of the session? Okay.
Thank you.
So we could go to our next speaker, Professor Vimal Katia. Professor Katia is a distinguished faculty member in the Department of Chemical Engineering at IIT Guwahati. He earned his PhD from IIT Bombay, MTech from IIT Kanpur, and BTech from Hardcore Bartler Technological Institute, Kanpur. Since joining IIT Guwahati in 2011, he has progressed from assistant professor to full professor in 2018. His research interests encompass synthetic and natural polymers, polymer processing, biothermoset, nanobiocomposites, and organic solar cells. He serves as the Dean of Research and Development and coordinates several centers of excellence, including the Center of Excellence for Sustainable Polymers and the NRL Center of Excellence for Sustainable Materials. Internationally recognized, he holds position as a visiting professor at Jibu University, Japan, senior fellow at Kyoto Institute of Technology, Japan. His contributions to polymer science has been acknowledged through various awards, such as Dr. Jane Barua Science Award in Chemical Sciences. Welcome, Professor Katia.
Thank you very much, Chair. So I'm really very happy. First of all, thanks to Dr. Tanveer Alam, who have invited me for this wonderful meeting. And I'm very happy that I'm in the third day standing before the audience who are really interested on the research. So I really feel be very happy to be in a research conclave. Though these days we used to give a lot of talk here and there, and if you're really going to see in the title of my talk, somewhere the standards and all those things are written. I'm not going to speak on those. And if you have any concern or thing, you can always raise a question on this. I'm very happy going to talk about the small research what we have done at IIT Guwahati. It's not cover all. I will speak less so that more content has to be covered. It's a very basic presentation, and the presentation is given for the students. Yeah, northeast, now not far. It is very close, 2.5 hours from Delhi with a flight. And with if you wish to see the wonderful institute, that Indian Institute of Technology, which is situated in the Guwahati, which is the gateway of the Northeast. And the way the Northeast is developing, you will be really feel pride if you will visit there, and it will be as good as in Delhi and Bombay. Okay, so I really looking forward that my young student, they have to visit to Northeast and feel the difference. IIT Guwahati, as well with other IITs, we have very many departments, Center of Excellence and multidisciplinary centers. Okay, here at IIT Guwahati, we have a small lab, and this lab is basically doing on sustainable, developing a ecosystem for a sustainable polymers. And we initiated with the Center of Excellence for Sustainable Polymer for very many applications. Very much focus on how we can make it a bio-based polymer, resin, product, and disseminate as end-of-life option as a compostable polymer. For my students, when I talk about my talk focus on bio-based and biodegradable plastic. When I say bio-based, it means the polymer has come from renewable feedstock, and it helps to remove to have a sustainable carbon cycle, the shorter carbon cycle. And when we talk about the end-of-life option of this polymer, whether it goes in packaging or other application, it's called an end-of-life option. And basically why we are worried about, we could able to remove the safe, we can have safe removal of a carbon from environmental compartment. Because of these two reasons, we are very much worried. We are very much opportunistic to utilize this class of material. Okay, when we give an example of a bio-based polymers, you can say the biopolyethylene. It is same polyethylene that what we are using. Feedstock is a renewable feedstock. That's why we call it as a biopolyethylene. There is a company in Braskem in Brazil, and they are following it. It's not new. In India, I mean to say we are following, we are able to make it different chemicals, especially the plastic from renewable feedstock. There's a very old company, synthetic and chemicals, since 1950s they are practicing making a different kind of a plastic from renewable feedstock. Okay, so we'll talk about some glimpse here. Just I wanted to show you that the eco-friendly polymers may be a biopolymers like saccharides, it may be a bio-derived polymers like polylactic acid, or maybe a polymers which can petrochemically derived, considered to be a compostable, biodegradable, lot of terminology we used. Here I would like to talk about some of the polymer which you practicing day to day considering to be a compostable polymer like polylactic acid. You know that polylactic acid, it means it made from the lactic acid or a lactide. We understood that it is a good polymer, can be replaced very many plastics, whether it's a polyethylene, polypropylene, polystyrene and other. But if you're really going to talk about, I would like to tell you that one of the company in the country who would like to come up with the 80,000 KTA plant of the polylactic acid, it is the first of the bioplastics that India is going to experience. Still, there are different other organizations who are making this polymer, but still that company will come forward and making this polymer, but it still may not be able to sustain in certain areas. Like if you want to use this polymer for heat application, I mean to say heat application, if you would like to make it as an engineering polymer, if you would like to make it use this polymer for a packaging application, especially for carbonated drinks or high barrier packaging film, or the food for the perishable food for So there are still limitation exists for this polymer. Some of the research I would like to show you that how we can able to overcome these limitation based on so-called bio-nanocomposites, what we have developed. Packaging is very important, very important sector as far as the plastics are concerned, and we have debated for last 3 days. We know you understood all about this. 40% of the plastic used to go for a packaging. However, the food packaging share is out of 50% in this 40%. Mostly 99% conventional plastic we used, and we have debated how we could able to optimally design the packaging product and finally disseminate for its application without harming the environment. My personal feeling that plastic is a wonderful material. We can't live without the plastic. Okay, so we have to optimally design for its applications. I'll talk about we have our own facility for development of these kind of polymers. We have a 200 kg pilot plant for manufacturing this kind of conventional pilot plant for polylactic acid. It is a unique indigenous plant. It's the first of its kind in the country that we used to produce with our technology. And our footprint is in all continents. We have our footprint in order to keep this technology with us. I would like to talk about the packaging. If you really would like to replace this particular polymer, you can see plastic packages for removing replacing a conventional plastic. You can see it here, like we could able to replace a polyethylene, polypropylene, polystyrene based packages by using PLA, but when we are going towards a PET, replacement of PET, you can see the oxygen barrier properties are important. We have to reduce oxygen transmission rate by 10-fold, water vapor transmission rate by 2 to 3-fold. If you really would like to have a bioplastic, this class of a material for a packaging application for these kind of stringent food packaging applications. We have made a various attempt, and if you're really going to see in the literature, a lot has been done. Earlier the trend has been started like to make it a nanocomposite. The clay has been used, and these kind of the layered clays has been dispersed into the polymers at a nano level in order to reduce the diffusivity coefficient. And because of reducing the diffusivity coefficient, we could able to reduce the permeability, and that was the concept behind it. But if you're really going to see, we tried to reduce to disperse these kind of a clay. If you can see, the clay platelets has been distributed into polymer matrix with less than 4 nanometer. We could able to make an intercalated morphology, and in some cases exfoliated morphology, which is important for reducing the diffusion coefficient. But finally, when we did this, we made a nanocomposite films, you could able to see that we can only reduce the 60% of oxygen transmission rate. That is not desirable. And you can see the distribution of the clay platelets is around 1 nanometer, that what we have established. But doing all possible research, we could able to figure it out. This is tailoring the diffusivity coefficient in order to reduce the permeability or oxygen transmission rate. It's not going to work it out. We try to figure it out another dimension, because permeability is a function of a diffusivity coefficient and a solubility coefficient. Then we realized that let's work on the solubility coefficient, and we have utilized a different kind of a biofillers. I mean to say cellulose, starch, silk, chitosan, all these kind of biopolymers, we try to make it a nanomaterials, nanoparticles of it, and try to disperse. These are hydrophilic in nature. Dispersing in a hydrophobic polymer is a really difficult task. So originally, I mean to say, we have initially what exactly we have taken, because you know the chitosan nanoparticles is the hydrophilic in nature. What we have done, that we made the chitosan as a hydrophobic, and then we disperse into the PLA matrix, and you can see the distribution of chitosan particles is around 40 to 50 nanometers, and it has been dispersed very well in the PLA, and in that way we could able to reduce the oxygen water vapor transmission rate by 2-fold. And if you're really going to see the oxygen, this is another example. We can use a chitosan as well as we can use a polysaccharide also, guar gum we have taken, and you can say the reduction of oxygen transmission rate has gone down around 10-fold by only using the solubilizing these class of material into the polymer, So the fact that using these kind of interventions, bringing a biopolymers with the synthetic bioplastics and dispersing it nicely. It cannot be dispersed directly. You have to modify these bio-nanoparticles and disperse it. So you can see this is an example we have done at semi-industrial scale process. Okay, I'm just skipping that is a residue. Another I would like to tell you that the nanocellulose is also important biopolymer. We talk a lot about cellulose. Here the nanocellulose, if you're really going to see the feature of nanocellulose, is a large surface area around 600 meters square per gram. Having a functionality, because of it, we could able to use for very many applications, especially for the packaging, and also for the, I would like to tell you, the recycling the biodegradable plastics. So we could able to make cellulose nanocrystals by using various feedstock, and these days what happened, I would like to, there is a limitation of cellulose nanocrystals, so that we have gone to the making a nanocellulose by using a mechanical processing. But here I'm just going to show you various applications we have shown. The nanocellulose having a good application in food packaging applications in order to improve the barrier properties and increase the recyclability of the polymer. Here what we have done, we have taken a PLA and dispersed the cellulose nanocrystals. So when you disperse the cellulose and graft the cellulose nanocrystal PLA strength has gone down, melt strength has gone down. That will be, it will be used for the industry. You could able to see the normally 13 centimeter wider print out of 20 centimeter coming from the slit die, 13 centimeter we can get, a lot of knacking has been found, but you can see after adding a nanocellulose around 0.5%, we could enhance the melt strength of the polymer, and finally 20 centimeter slit die has given an 18 centimeter film on the winder. So that is a good thing. Another I would like to tell you, if you use this class of chemical and graft it, you can able to recycle the polylactic acid. So using this kind of a nanobio material, if you put it into the polymer, you can recycle. We have experience to recycle a PLA 3 times without, there is a decrease in the tensile strength, but it is always be higher than the tensile strength of a LDPE, what we are using, more than 30 megapascals. I mean to say we have done the I mean to say as far as the migration properties are concerned, by using as per the, so we have done the shelf life of this stored food in using these kind of bio-nano composites, and we got good results as far as based on the standards. I'm just skipping, this is another slide. I would like to tell whether we take a nanocellulose, we can also take a nano silk also, because northeast, if you go, the Muga silk is a very popular. So we tried to, if there is a waste of the Muga silk, can we make it use it for a high value product? We could able to make it a nano silk also. This is the first time we have demonstrated a nano silk with a thickness of around 5 to 7 nanometers and the diameter of 40 to 60 nanometer. And that disc we have grafted with a PLA, and we could able to figure it out during the processing. Because the polymer is sensitive in a thermal at a temperature, higher temperature during the processing, we could able to reduce the degradation by using this class of a material. These some certain articles has been made. Anyway, another class has come whether we can use the PLA for a heat applications. So we could able to make, utilizing the biopolymer, we have made a heat stable PLA, which is a stereocomplex PLA by using the chitosan and the cellulose grafted in it. And these, when we talk about the stereocomplex PLA, basically it is made of LPLA and DPLA. We have grafted a DPLA with a flexi plasticizing chain, and once it comes together, so I would like to tell you a lot of research has been done, but most of the research has been done for making this polymer, I mean to say stereocomplex polymer through a solution processing. And as far as the industry are concerned, solution processing is not a viable option. We have made the stereocomplex polymer and make it a stereocomplex nicely. I would like to show you the structure. What is the importance of the stereocomplex PLA? You can say the heat deflection temperature goes to 160, 170 degrees centigrade. In respect to the normal PLA 55, 60 or 65 degrees centigrade. Time is limited. Yes, I'm just skipping here, and I would like to show you the heat deflection temperature has been increased significantly. This video I just want to show you, though this is a bit old. This is the conventional biodegradable polymer, and if you're really going to pour it to our designed containers, so you can see the deformation. And, okay. So if you are pouring it, the stereocomplex PLA, what we have designed, and this through an industrially extrusion process, it's quite stable. Thank you very much. And a lot has been done because the similar kind of biopolymers, if you're really going to use for a medical application, we could able to make it different fixation devices that would be useful for a application. So certainly we also do the composting studies and the studies of these class of polymers and how it's going to affect into the cultivation of the different kind of the crops. We have found that very good results. It's a positive result as far as the cultivations are concerned. So I mean to say such certain class of polymer is considered to be degradable as an industrial compostable polymer. However, in certain cases we have developed our lab synthesized polymer which used to go even in a soil degradation. So that is a new, I mean to say this is a new concept like PLA is industrial compostable, could be able to come up with a PLA which is going to be a soil compostable. Those investigations, those know-how we have developed. Okay, these class of bio nanoparticles, and these bio nanoparticles has been introduced to the synthetic biodegradable plastic in order to enhance the properties. Another thing is that we could able to make an edible coating with using these nanoparticles. I would straightforward going to this. You can see that the different kind of the fruits and vegetables, and if you're really going to see the top tomato, onion, potato, we could able to increase the shelf life by the 2 months. For tomato, 1 month. If you're really going to talk about the apple, it's going for 1 month. And other chili, kiwis and bananas, we have done this. So because of this, and also packaging is not only important in the packaging, what we do it, also important to how to disseminate the certain product in, I mean to say the urea. We are packaging the urea particles also in order to increase the efficacy of the nitrogen. Right now 30% nitrogen goes into the plant. Our target is to make it a 60% nitrogen to be an uptake to the plant so that we can reduce the consumption of the urea or the fertilizer and pesticides. So this is a government project. We do it a lot. I'm just skipping the slides. So I'm just talking about these nanoparticles where it can be used significantly in very many applications. Recently what happened, we are also utilizing these kind of concepts in biodegradable toy centers. Basically here, this is today is a Women's Day. I would like to tell you this is a mission of my center, that how to empower the women of my rural villages. And here these 4 villages has been adopted, and our job is that how to provide a 15 to 20,000 rupees a revenue per month to the woman who is in the village by using hand-holding with the industry of 4.0 and the craftsmanship skills what they have it. So basically this project is going successfully, and we are now working on it. Many women, more than 200 women have participated. Our job is now, our mission is that make it 6,000, 10,000 women which will be making a biodegradable toys, and that has to be disseminated to the national and international level. So you can see that the trainings has been provided, empowering them so that they will come up with a customized high value added kind of a product. So this is the Department of Science and Technology intervention with IIT Guwahati. And we also empowering because we have a CRTDH, Common Research and Technology Development Hub for MSMEs, and our job is to empower the industries, empower MSMEs. So we are giving a hands-on training to them. I mean to say they have to come and see that when we talk about PLA, how to make the PLA, how to make the PBAT, how to process the material, what are the limitations. Let's come and 3 days discuss and see yourself and do it together. So that's what these kind of inventions we are doing with this. Thank you very much.
I'm really sorry to interrupt Professor Katier's talk. It was so interesting, but it's so elaborate. I think separate session should be given to him. Now I invite Dr. Sudhanshu, Secretary, APEDA. Dr. Sudhanshu serves as the Secretary of the Agricultural and Processed Food Products Export Development Authority, which is APEDA, under India's Ministry of Commerce and Industry. He holds a PhD in Commerce and postgraduate degrees in Business Administration and Computer Applications. In June 2005, he participated in the Food in Agribusiness Management program at Cornell University, USA. With over 32 years of experience in the agricultural sector, his responsibilities at APEDA encompass statutory functions, personnel and administration, common infrastructure, animal products, agri-export policy, logistics, parliamentary questions, library management, and export analysis. Dr. Sudhanshu, please.
Thank you very much. The speakers at the dais, the chair and the rapporteur, and all the participants in this hall. Good afternoon to all, and on the occasion of the Women's Day, the women force of the country sitting in this hall, I would like to compliment and congratulate them. And would like to compliment Indian Institute of Packaging also for taking this wonderful initiative for organizing this 3-day conference. Packaging, we all know how it plays a crucial role, and in the 3 days, I think lot have been discussed, though I am not expert in the packaging area. But I am at the other side of where the packaging is to be used for the safety of the product, for increasing the shelf life. I represent to an organization, as per the background already informed. It's APEDA, Agriculture and Processed Food Products Export Development Authority under Ministry of Commerce and Industry, which is responsible for promotion of agri-exports from the country, and it accounts for more than 50% of total agri-export. I will not go with my presentation because that does not seem to be making a presentation in the front of the experts. Why I'm saying the experts from the academia and the industry. So I would like to present a different perspective, though the topic allotted is the roadmap for innovative packaging. So as per the perspective of agri-export, if we see, APEDA looks after more than 50%, which comprises of fresh horticulture, fruits and vegetable, processed food, animal products, which is meat, poultry, dairy, honey, and cereals, rice. And in every product, the packaging plays a crucial role. Though country being an agrarian economy, and we are able to, or the country is blessed to grow from Kashmir to Kanyakumari, all kind of produce we are able to produce. And we all know that due to the challenges being faced, the kind of post-harvest losses or the limitations in increasing shelf life, we are not able to utilize the production whatever we produce, whether in the domestic market or the global market. Why I'm mentioning about domestic market? To cite few examples, because country is so vast, the produce grown in the northeast part of the country or the eastern part of the country, the perishable product we are not able to get reached to southern part of the country. For example, the lychee from Bihar, it is such a perishable product. Or the passion fruit from northeast, we are not able to, in the country, from one corner to one part of the country to another part of the country. So the APEDA has been working, because APEDA and Indian Institute of Packaging both comes under the same ministry, and IIP being the premier institute, the government institute in the country for development of packaging standards. So we have been closely working since last so many years, or from the inception of the organization. And through IIP we have developed packaging standards for fruits and vegetable, processed food, and recently a project has been awarded, and Dr. Tanveer Alam has been instrumental in getting the project expedited, and a lot of work has already been done. I think it might have been showcased here also in this. So I would like to focus on the challenges which are being faced, some of the examples. For example, in the horticulture basket of the country, the few products which are being exported in good quantity, though a number of other products are also there, mangoes, grapes, banana, pomegranates, these contribute to the major chunk of the horticulture basket, though we have guava, papaya, sapota, a number of products. Those products we are not able to export due to a lack of the proper packaging, because we are not able to retain the shelf life which is required. In case of mangoes, we are one of the leading exporter. In case of grapes, we are the leading exporter. But despite we are having all the advanced technologies and other requirements, we are not able to ship this fresh produce by sea, except grapes. Grapes that too, to the cold chain treatment, we are able to export to EU market but mangoes and banana, we are not able to export by sea only. Reason because the proper packaging standards are not there. And if we are able to have those packaging standards, we will be able to send container loads to a far distant market. For a far distant market, when we say it is to CIS countries or Europe or US or Canada. US, we are exporting mangoes more than 2,000 metric ton by air. And by air, we all know that the logistic cost is so high. And if we are able to have the proper packaging standards or the protocol, we will be able to at least send huge quantity of these perishable products. And the country is very rich and we have a vast production base. APIDA has taken initiative for developing the standards for this lychee and passion fruit. With a private service provider, we are in a process of getting the standards developed. Lychee, we will be making a trial from 4 locations from Bihar, from this Pathankot and Uttaranchal, 3-4 locations in the coming bleaching season. Though that will be a trial season, we will able to have the shelf life of 15 to 17 days. In case of passion fruit, though the project is still going on, we were able to retain up to 22 days. So on this forum, I would like to request the packaging industry to come forward, collaborate, and through Indian Institute of Packaging, we would like to invite the industry or the academia, the research scientists who are sitting here. We can collaborate and let us try to work jointly for developing the packaging standards. And in case of the processed food also, there is a lot of scope, because when we visit the international trade events, APIDA organize participation of its exporters in leading trade events like Sial, Panuga. Recently we organized the participation of over almost 100 exporters in Gulf Food Dubai, which is one of the leading trade events. When we visit these trade events, we are able to see the kind of packaging innovations, actual packaging innovation we come across there. I am not saying that India, we are so down that we don't have. We have, but whenever we come across with the kind of innovations there, so we always tell our exporters that by participation in such trade events, at least you are not able to only expose your product, but learn also what kind of packaging, what kind of labeling, what kind of customization in the product is required. So I would request the industry to come forward, collaborate through Indian Institute of Packaging. We would like to welcome. And any of the product which is looked after by APIDA. APIDA looks after 700 plus products for promoting the agri-exports. So anyone who have the idea how the better packaging can be done, what kind of solution can be generated for having more shelf life of the product, because if we are able to increase the shelf life, that is a major challenge. And in case of horticulture product, I don't feel that it's a robotic science. Having a C protocol is basically a combination of the post-harvest on what maturity index the produce is to be harvested, and the logistics part with packaging and the logistics. So it can be very well done. Would like to cite an example of banana. And you might have heard that the leading giants in banana, which are Del Monte, Dole, Chiquita, and the country like Philippines. Philippines is a small country. They are leaders in banana, only with the kind of the production, then packaging, and having the protocol. And the Ecuador, they have banana ships, banana port. India having the vast production base of banana, we are not able to utilize the potential of the country. So much of a scope is there. If we try to identify the products, I think we will be able to identify more than 50, 60 products which can be very well exported to the global market, and not only exports, but our citizens of the country, because the citizens of the country also deserve to have a good product in terms of the quality of the product, and the quality of the product is directly related to the packaging, if the proper packaging solution is there. So I know though a lot can be discussed, the program has already got delayed. Thank you very much. I would like to wish the organizers and the participants for the further remaining part of the session. Thank you very much.
Thank you, sir. I'll now invite Dr. Kirti Raj Gaikwad, Associate Professor at IIT Roorkee, in the Packaging Technology Division. He earned his PhD in packaging from Yonsei University in 2018 and has degrees from Michigan State University and Dr. Panjab Brau Deshmukh Agricultural University. He is a fellow of Linnean Society of London and worked as postdoctoral fellow in Canada from 2018 to 2019. He has received several prestigious awards. Dr. Gaikwad has published over 120 research papers and holds 8 patents, and he has edited 3 books on food packaging. His research, valued as over 11 million Indian rupees, focuses on sustainable materials, advanced packaging technology. He teaches graduate students and guides PhD candidates in food packaging. Welcome, Dr. Gaikwad.
Thank you, Professor Datta. A very good afternoon. I'm Professor Kirtiraj Gaikwad from IIT Roorkee. Before moving on to my presentation, one quick question. How many of you really use Zomato, Amazon, or the new apps? Please. Okay, so almost all of you, right? That means whatever I'm going to talk today, it's your daily to daily part of life. And this is very close, this is very interesting area, which is now we need to understand, because we are extensively using these apps in daily to daily life to order something, anything like food or electronics or whatever it may be. And the importance of the packaging is going to be, getting boomed because of this app. It is not just about the 10-minute delivery, but it's about to deliver your product safe and secure, because that is what you are paying. You are not paying for the package. You are paying for your product. And yes, as a packaging engineer or as a packaging professional, it's our responsibility that we should understand this new era of, e-commerce, and again, the new concept is like Q-commerce, that is quick commerce. So I'm going to talk about what kind of, chains of the packaging they commonly utilize in the packaging. 10 minutes delivery they claim, but most of the time they use the paper-based packaging without any cushioning material. And that is what the packaging challenge is. And one more interesting thing is, if you notice, the use of paper-based packaging, which is huge, especially in this era. We are talking about, from last 2 days, we are talking about the biopolymers, polymer packaging. But yes, the paper-based packaging is again the next generation packaging material, which is going to be being boomed. And that is the reason why there are a number of researchers who are working on this paper-based packaging in different applications like barrier coatings or the strength and some other factor. So I would not say that this material is bad or that material is good. There is no perfect material on this earth. Every material has their limitation. It's up to you guys, it's up to consumer how they utilize. Every material has their own unique characteristics, like paper has really, good property towards sustainability. Plastic is again very unique material. And some people, they generally talk about the replacement of, I generally say why we need to replace any material. We just use some segment of that material so that we can utilize, in the proper way. So, as you can see in the graph, the trend is going for this kind of the packaging material which is used in the e-commerce and the Q-commerce companies. Now, sustainability is the most abused word in today's era. Everyone utilizes sustainability, green, organic, and herbal, because these are the marketing keywords. Even you are utilizing, for example, points or some few percentage of biomaterials. They claim that, okay, this is the green material. So it is up to you how you utilize or how you tackle this keyword, that is sustainability. Some polymer guys say that, okay, paper industry is not sustainable. Paper industry say that, okay, polymer is not sustainable, we are the stakeholder. I would say I'm the packaging engineer, I need both. I need plastic, I need the paper. I cannot differ. According to application, I should utilize. So, when we talk about the balancing all these concepts, you must have noticed that when you order some food or when you order some vegetables from the Q-commerce company, apart from the bag of the paper-based bag, you will get more, small packages into that. So that means you are literally generating the waste. And if I ask you, what is the life of the package? So some of you might say that, okay, 1 year, 2 years, or maybe 5 months. I would say your life of package is a few minutes. Once you get the product, after delivering the product on your doorstep, your package immediately become into the trash. Nobody cares about the package. The value of the package only till the product is inside. And this is how we are generating literally the huge waste of the packaging. Doesn't matter, paper or the plastic. The fact is, we are generating the waste. Challenges, obviously, there are a number of challenges. When we talk about the delivery, the safe product delivery, we do not accept any product if there is a package is damaged. We don't even care about whatever the product is good or not. So that is very important. And now, most of the time, like, cushioning material, EPS is already get banned. So as a packaging engineer, there is huge challenge to protect your product safely during especially the transportation, especially when we talk about the Indian road condition. We need good barrier, we need cushioning material, we need good, proper compression strength based boxes. And in this condition, especially when we talk about the e-commerce or the Q-commerce, in that case, this kind of packaging is very important. And obviously, challenges is there. There are a number of companies, they claim that they are so-called, biodegradable or biocompostable. But in reality, my question for you again, how many of you really want to pay extra pennies for sustainable material? Nobody wants to pay when it comes to the reality. But can you imagine when you go to some so-called branded shop, for example, Bata or the Adidas, you are ready to pay 15 rupees for one paper-based bag. In that, billing counter, you never ask, no, I don't want this. But researcher or the, manufacturer, when they develop any kind of packages, sustainable packages, the first question gets asked by the audience is, what is the cost of per package? So my belief is, it depends on what kind of area you are focusing. We don't need to replace any material. We just want to focus one segment or one sector. So challenges are there, and obviously the cost is always, barrier in development of all this kind of stuff. When we talk about the material, I believe the concept of waste to worth or the waste to wealth. Because this is what we need to, at the end of the day, we need to understand. There are a number of biomaterials, I'm not going into the detail, but that we should utilize into the, what we call in the quick commerce or the e-commerce company, especially when we talk about the fruits and vegetable packaging. And in that case, it could be like starch-based, cellulose based, or for example, the protein based. Paper based is already, huge demand for bags or the cutleries or some other stuff. The right packaging material is very important. I will give you one example. I'll not take much time. When one day I order one shirt from so-called, famous company, and my shirt was wrapped in the bubble wrap. Can you imagine why do we really need the bubble wrap for this shirt? It is not fragile material, right? But, overuse of packaging material, that should be avoided. Otherwise, we are literally generating the waste. Right kind of the packaging, according to the product, that should be utilized in the packaging material or in the package. When we talk about this kind of the cost saving concept or the reduction of the waste, that is the only thing that we can utilize the proper designing of the package and the usage of right material in some quantity. You should not, as a packaging professional, you should not compromise with the quality, because ultimately our goal is to protect your product and not to just protect the cost and some other factors. So there are definitely challenges. When we talk about the lightweight packaging, I'm not sure how many of you is from 90s era, but if you remember the 90s era, the glass bottle was very thick, the thickness of the glass bottle. But if you see now, the thickness is getting reduced. So demand for lightweight packaging is getting again very important. And this will change according to, year by year and according to the research. Smart packaging, obviously, because the supply chain involves in the e-commerce and Q-commerce company. So smart packaging like oxygen scavenging, or for example, when we talk about the fruits and vegetable delivery, ethylene scavenging is very important. And this is not just, developed country are using. Believe me, in India also, we are extensively using the oxygen scavenger and the ethylene scavenger. So smart packaging technologies obviously play a very important role. Protective packaging, because expanded polystyrene based cushioning material has already banned. So now people are exploring new opportunities that is based on what we call the paper based packaging. And I'm sure we will get that cushioning properties or cushioning effect from these kind of material. Also, I'm from the IIT Roorkee is based in the Uttarakhand state. So we also utilizing some forest waste into the mainstream so that we should not need to cut the trees, or we should not always depend on the regular, what we call the cellulosic pulp. Frustration free, like in the morning session, someone was talking about the frustration, like, peeling or the opening of that, what we call the tomato ketchup packaging. So that is what we call the frustration packaging. So your package should not frustrate the consumer. It should, give convenience to the customer. That is what we deal. And yes, paper-based packaging is the one segment through which we can, get this all kind of practices, like, for example, the frustration-free packaging. Returnable or reusing of the package. This is again the one major area, especially in this case. For example, just imagine if Zomato or, for example, the Blinkit, they are ordering something, and at the end of 1 month, they are collecting all the baggage from your, home. So this kind of return packaging concept can definitely help to reduce the, what we call not only the food waste, but also the packaging. Yeah.
We have to actually, we're running out of time.
In this concept, definitely is very important. This is the one common example by the Amazon, that is frustration-free packaging. I mean, you can really, access easily packaging. Few more. So what is the role of academia when we talk about IIT Roorkee, my lab, we are extensively working on this concept. That is, for example, in the morning opening session, director Millets Research Institute, she clearly mentioned that there is a development of millet-based cup. So I'm proud to say that is from my lab. And one of my students, again, she is going to present, she developed the edible, what we call the straws from the millets. We are trying to find some alternatives to the paper-based and the PFAS contained straws. So it's not like as a IIT researcher, we are working on, just research-based or the lab-based, but we are extensively working on the commercial aspects packaging. So this kind of packaging we are working, and bio-nanocomposite or the biocomposite, that is again the one area that we are extensively working. So in the conclusion, we should say that, or I should say that it should not, of course we should think about the sustainability, but we cannot compromise with the quality and the protection of your product, right? And with the use of bio-based material that we can utilize in the future for our commercial application of the packages. And yes, I would say sustainable, smart and efficient, which is the theme of this conference as well, and that should be balanced and the protection according to sustainability concept. So that's it for today. Thank you so much for hearing me, and thank you, sir.
Thank you, Dr. Gaikwad. I'm sorry to hurry you. We are running short of time, so the questions, I know there are questions, one or two quick questions may be there. It can be the lunch session that can be utilized. Okay, thank you very much.
Thank you so much, everybody. It was a wonderful session. May I request Honorable Chairs, Dr. Bindu Ranjan and Professor Anindya Datta, to felicitate our speakers, starting with Dr. Sumer Singh. May I request you please to take the center stage. Dr. Sumer Singh. Great round of applause, everybody. Thank you so much, sir. Professor Dr. Vimal Katiyar. Great round of applause, everybody. Thank you. Dr. Sudhanshu, sir. Dr. Kirtiraj Gaikwad, sir. May I request Professor Tanveer Alam to kindly felicitate our honorable chairs and co-chairs. Professor Anindya Datta, Dean USBAS, Indraprasth University. And Dr. Bindu Ranjan, Associate Professor, USDI, GGSIPU. Sir की photo रह गई. Sir की photo रह गई. I request all the speakers to please gather for a group photograph. Thank you so much, everybody. I request Dr. Madhav Chakraborty and Mr. Mayur Katiyar to kindly take their chairs on the dais. Just briefly introducing our honorable chairs. Dr. Madhav Chakraborty is a distinguished packaging consultant with an experience of over 34 years in the packaging industry. He has served as the Joint Director and Regional Head of Indian Institute of Packaging, Delhi before retiring. Currently, Sir is the Founder Director of Dr. Madhav's Packaging Consultancy and Management Solutions LLP. Throughout his career, he has provided consultancy services to over 65 companies, showcasing his extensive expertise in packaging solutions. Welcome you, sir. And Shri Mayur Katiyar, Scientist C, Textiles BIS. Sir is a BTech in Textile Technology from UP, Textile Technology Institute, Kanpur, and an MTech in Textile Engineering from IIT Delhi. Currently, he is working in Bureau of Indian Standards as Deputy Director and handling the areas of protective textiles, sport tech, cotton, man-made fibers, and its products. Welcome you, sir. Now, I would like to call upon the speakers, the esteemed speakers for this session. Dr. Preetam Sarkar, Associate Professor, NIT Rourkela. May I request you, sir, to kindly come up on the dais and take your chair. Ms. Sonal Chaudhary, Publisher Applied Sciences, Springer. Request you, ma'am, to please come up on the dais and take your chair. And Dr. Narendra P. Raju, Senior Scientist, Food Science and Technology, NDRI, Karnal. Request you, sir, to please take your chair on the dais. Over to you, sir.
Hello. Very good afternoon, ladies and gentlemen. This ISPI last 3 days is going on, and today is the last day, last session. And it's a wonderful session is going to be held now. We have 3 speakers in this forum, and all the topics are very interesting. We have with us Dr. Preetam Sarkar, Associate Professor, NIT Rourkela. We have Ms. Sonal Chaudhary, Publishers Applied Sciences, Springer. And third speaker is Dr. Narendra Raju, Senior Scientist, Food Sciences and Technology, NDRI, Karnal. So before this presentation starts, I would request Mr. Moyuk to give the profile of Dr. Preetam Sarkar as first speaker.
Thank you, sir. So Dr. Preetam Sarkar is Associate Professor in the Department of Food Processes Engineering at NIT Rourkela. He earned his PhD in Food Sciences from Purdue University, USA 2014, and his MS in Food and Nutritional Sciences from California State University, Fresno, USA in 2010. Dr. Sarkar's research focuses on valorization of agricultural and food processing byproducts, particularly in developing bioactive food packaging systems. Dr. Sarkar.
And me an opportunity to present the work of our lab that we do at NIT Rourkela. Okay, so the topic of my presentation will be agro-food byproduct valorization for sustainable food packaging. That is what we have been working on for the past at least 7 to 8 years. We have been trying to focus on the valorization and value addition to agricultural byproducts. So just briefly, the NIT system, we all know there are 31 NITs across the country which provides undergraduate, masters and PhD programs. And we are the only NIT Rourkela which has a BTech and MTech and PhD programs in food process engineering. So briefly, this is NIT Rourkela, which is in the eastern part of the country in the state of Odisha. This is, you can see our department at the main buildings, and then in the world rankings, we are also in around 291 to 300 in the Asia rankings and 67 Southern Asia rankings. Okay, so the overall research theme of our work is to focus on 2 aspects, that is environmental safety and circular bioeconomy. We have been hearing these terms for the past 3 days, both environmental safety and circular bioeconomy, as well as to focus on food safety. So we want to I mean, we all know that these two are global problems, and therefore we have to find a unique solution, uniform solution which can be used to face and tackle both these challenges at the same time. And with that, so if we want to target these two problems, our ultimate goal is to target the preservation of the food systems using biopolymer-based technologies. Okay, so now we all know that the food packaging system is, the food system is very delicate because it is under threat from different stress factors, starting from light to physical damage to temperature, environmental pollutants, microorganisms, oxygen, mechanical damage, water vapor. So many parameters can affect the food system, and therefore we need to provide a food package. And we all know that the synthetic food plastics that creates the environmental problem, environmental pollution, so we need to focus on the bioplastics and biological derived polymers. Now, if you just do a Google search, and you can find out that the major issues related to environmental sustainability, you will find so many issues, so many articles in the top magazines like National Geographic that plastic food packaging was the most common beach trash in 2018, for example. Okay, and now this is the recent news from 2024 that India is now the largest leading plastic polluter, overpassing China. So therefore, if you do a research, search in Science Direct, for example, or Google Scholar, you can find so many articles focusing on the impacts of the synthetic plastics and synthetic polymers from the food industry on the human health, which is affecting the human blood, and it also can surpass the intestinal barrier and accumulates in the body, for example. And then these plastics can convert to microplastics and nanoplastics and can cause brain abnormalities, and also microplastics can lead to lot of issues, especially in the seafood industry, because the seafoods are from the marine organisms, and therefore there's a big issue of the microplastics and nanoplastics in the seafood industry, for example. And therefore, again, if you want to combine all these parameters together, you have these two global problems. You have from the environmental safety aspect and the food safety aspect, and we got to need to provide a unique solution which can be used to target both these concerns. So therefore now the focus is on biodegradable polymers, and then we focus on these renewable polymers or biodegradable polymers. Now we know that there are so many materials like starches or PHA, cellulose, PLAs, and so many stuffs. And then we also have these agricultural byproducts. So now the goal is to produce this is to secure these biomaterials from the agricultural byproducts. Okay. Now when we talk about byproducts, we can get starches, for example, from different sources. Like we can have jackfruit starch, we can have jamun starch, we can have lychee starch, for example, which we have used in our works and try to convert those into biopackaging materials. And then we also work on something that is very unique, which is called the class of hemicelluloses or xyloglucans, which are obtained from tamarind, because India is one of the largest tamarind producer in the world, and then we have a lot of xyloglucan production, or is a class of hemicellulose that can be obtained from tamarind seed powder or tamarind kernels, and that can be used for production of these biopackaging materials. So with that, our research direction is to produce bio-nanocomposite materials by combining starches and xyloglucans. So with that, we'll talk about three different models. The first one we used, in the first one we used jackfruit seed starch combined with tamarind kernel xyloglucans, and we try to functionalize that with zinc oxide nanoparticles. We select zinc oxide nanoparticles because it's one of the safest metallic oxide nanoparticles, and it can be used as food and food packaging systems as per the US FDA standards. So these, if we can see briefly, these are our FESCM images of the jackfruit seed starch and the tamarind kernel xyloglucans, and also the zinc oxide nanoparticles, and then the XRD profiles. And then we did the rheology of the film forming dispersions. We can see that the most viscous was the xyloglucan alone, and then the least viscous was only the nanoparticle with the 5%. Okay, and then we also did the FESM characterization of the film surface, the morphology, and we can see that as we increase the zinc oxide nanoparticle concentration, the surface roughness of the films increases. And along with that, we also performed the molecular study, molecular characterization. We did FTIR, we did XRD, and with the thermal properties, we did the DSC, for example. We can see that there are reduced peak. As we check the FTIR profiles, you can see there's a reduced peak intensities as we increase the zinc oxide nanoparticle concentration. And you can see that as we do our XRD profiles, there's a masking effect by the zinc oxide nanoparticles. And we also performed the optical characterization, like your color properties, the LAB values, for example, and the transmittance at 660 nanometer and 280 nanometers. And then we also did the physical property characterization, starting from thickness, moisture content, water solubility, and contact angle. Contact angle is a very important parameter for food packaging applications because we want to make the surface as hydrophobic as possible. So with an increase in the contact angle, surface contact angle, we could see that as we increase zinc oxide nanoparticle, the contact angle increased from 58 to 78 degrees for the 3% nanoparticle concentration. Then we also performed the mechanical properties starting from tensile strength, elongation and break, Young's modulus, and the barrier property we could did only the water vapor permeability, and we could see that as we increase our zinc oxide nanoparticle concentration, there is a significant increase of tensile strength from 8.03 megapascal to 25.9 megapascal, which is alone for the tamarind xyloglucan films alone. Similarly, for the elongation break, there is also an significant increase from 0.23 gigapascal to 0.55 gigapascal, and the elongation break also increased from 14.28 to 35.9 percentage. Similarly, as we increase the zinc oxide nanoparticle concentration, we can see that the WVP reduced from 9.51 to 7.56 grams per meter per second per Pascal. Now, zinc oxide, we selected zinc oxide because again, this shows inherent antimicrobial activity. So therefore, we could see that the zone of inhibition was quite active against gram-positive Staphylococcus aureus and gram-negative Escherichia coli. And finally, we did for the coating application by dipping application on tomatoes, and we could extend the shelf life till day 15 because we could reduce the weight losses till day 15. And this work was published in the journal Food Hydrocolloids in 2022 by my PhD student. And the next work, we tried to focus on using chitosan nanoparticles. In this particular work, we select jamun seed starch, and we select tamarind xyloglucan complex, and we modify with chitosan nanoparticles. But again, we select chitosan nanoparticles because chitosan also has inherent antimicrobial activity. Again, these are the raw material characterization. We can see that the TEM morphology of the chitosan nanoparticles and the FTR and XRD profiles of the raw materials. And this is again the rheology of the film forming dispersions. Then the molecular properties, again, you can see that with the raw materials, you can have a non-uniform microstructure, but as we start increasing the chitosan nanoparticle concentration, the films became more compact structure. Similarly, also on the right-hand side, you can see the FTIR, XRD, and the thermal profiles of the films. You can see that, for example, the melting temperature increased with the addition of the chitosan nanoparticles, and including the melting enthalpy. These are the films, the pictographs of the films, and the surface contact angle, again representing the surface hydrophobicity. We could increase from 49 degree to 86 degree. And we also performed the physical characterization, thickness, moisture content, water solubility, and the optical parameters. And then we performed the mechanical properties starting from tensile strength, which increased from 5.03 megapascal to 17.88 megapascal for the xyloglucan alone. And when we add chitosan nanoparticles, we could increase that to 20.42 megapascal, but that was not statistically significant, but still we could increase to some extent. Elongation break percentage reduced from 0.87% to 24.3 percentage, but on the other hand, the elongation break we could increase from 0.18 gigapascal to around 0.8 gigapascal in the case of 3% chitosan nanoparticles. And in case of barrier properties for chitosan nanoparticle based films, we could reduce the water vapor permeability from 6.41 to 4.32 at the 3% chitosan nanoparticles. Again, chitosan nanoparticles, just like zinc oxide, also shows strong antimicrobial activity against both gram-positive and gram-negative microbes. So we used Bacillus cereus over here and Escherichia coli as the model microbes, and we could enhance the microbial activity to around 10 and 9.45 millimeter zone of inhibition. And then we tried to apply that on a tropical Indian fruit that is called sapota fruit, which also shows very reduced shelf life activity, and therefore we could extend the shelf life to days 12, and we could reduce the weight loss percentage till day 12 as compared to the control. And the last work, this work was published in the International Journal of Biological Macromolecules in 2024 by my student. And the last work we're going to show is focusing on also this lignin nanoparticles, again our organic nanoparticles. Now lignin nanoparticles, they don't show antimicrobial activity, but what we could observe is they could see power, they could demonstrate powerful antioxidant activity. Okay, again, these are all your raw material characterization of the lignin nanoparticles and the raw materials. In this case, we use lychee seed starch and tamarind xyloglucan as the base polymers, and composites with functionalized with lignin nanoparticles. Okay, these are the rheology of the film forming dispersions. Then the molecular properties, again, we can see some aggregate formation and compact film formation. And as well, again, as we increase the lignin nanoparticle concentration, the surface roughness of the films increased. And we could also observe that in the FTIR profiles, there's increased peak intensities at around 3,300 centimeter inverse, which reached the formation of strong intra and intermolecular hydrogen bonding. And the XRD profile suggests that there is slightly reduced intensities due to reduced chain mobility. Along with that, we also did the film characterizations in terms of mechanical properties and physical properties and optical properties. Again, the surface contact angle could increase from 47 degree to 80 degrees, which is an indication of the surface hydrophobicity. And the optical properties, we can see that in terms of the LEV values. Again, our mechanical and barrier properties, the tensile strength, we could increase from 9.42 to 12.86 megapascal, and for elongation break, we could increase from 23.45 to 44.26 percentage, whereas the elongation break, the Young's modulus reduced from 0.42 to 0.424, but at 15% of lignin nanoparticles, we could go to around 0.41 gigapascal. And on the barrier side, on the water vapor permeability, we could reduce, with the addition of lignin nanoparticles, we could reduce the water vapor barrier from 8.49 to 5.63 gram per meter per second per pascal. Okay, and finally, because these lignin nanoparticles gives us antioxidant activity, we performed a couple of assays for testing the antimicrobial activity. We did the FRAP assay, and we did the TPC and the TPPH assay, and we could observe that as we increase our lignin nanoparticle concentration, there is a significant increase in both the TPC level and the DPPH scavenging activity and the FRAP activity. So suggesting that our films,
sir, you have to finish quickly within 1 minute time.
From lignin nanoparticles can be used as powerful antioxidant materials. And then we applied for the shelf life for the coating of banana food, small banana, the whole banana, and we could see that we could reduce the weight loss, and the hue angle and chroma was almost as comparable to the control. And this work was published in 2025 in the journal Food Chemistry. So these are our academic collaborators, and NIT Rourkela, Dr. Jassim Ahmed from Kuwait, Dr. Nandika, Dr. Kunal Pal, and Dr. Kirtiraj Gaikwad is also one of our academic collaborators. Dr. Srinivas Janaswamy from South Dakota State University, Dr. Sharup Roy, Dr. Masiej, Dr. Tizazu from Waterloo, and Dr. Vikramachichi from Sri Lanka. These are our students, PhD students and our master students who are our architect of all these works. And with that, these are our funding sources. I acknowledge NIT Rourkela for all the funding, our SERB. We also have some projects with the government of Sri Lanka, University of Kelania, and 2 projects with the Spark with the 2 universities in Canada, University of Manitoba and University of Waterloo, for on sustainable packaging. With that, thank you.
Thank you, sir. This is a wonderful session, and this is the basic research he has done on the packaging applications, and much more focused on the activities and physical properties, chemical properties, antioxidant properties, optical properties, and really it has given the lot of information in depth about his research work, which has a great application in the packaging. Thank you very much. Give a wonderful presentation, round of applause for him. Thank you. So I think question answering, we are keeping it for reserve for last. So now we'll be going for the next session. Next session we have speaker. She is Miss Sonal Chaudhary. She is a Publishers and Applied Sciences Springer organization, which is a world famous organization. So welcome Miss Sonal Chaudhary, and now Mayur will speak about her profile.
A very good afternoon to everyone. I'm truly delighted.
Just a second, ma'am.
Okay.
Ms. Sonal Chaudhary is publisher in Mathematics, Physical and Applied Sciences journals. The journal portfolio being managed by her comprises of the journals co-published by Springer, Nature of Partners, none other than IISc Bangalore, the Institutions of Engineers, IIT Madras, Indian Institute of Metals, Indian Geotechnical Journals, Indian Journal of Physics, and many more. Ma'am, thank you.
Thank you for your kind introduction, and I'm truly delighted to be a part of this event, and many congratulations to Dr. Tanveer Alam and his fully energized team behind organizing this wonderful event. So I know I have very less time. I'm not going to take much time of yours, so don't be scared by looking at the number of sections that I have here. I'll be trying to make it very concise for all of you. So we'll start with a very quick introduction about Springer Nature, the company that I represent. We'll then move on to identifying a good journal and what you should look for in a journal when you are trying to put your work of excellence into publication. Then what are the important points that you should know as an author so that you don't end up publishing in a predatory journal that will not look good on your CV. We'll then move on to the peer review process and how do we recognize the best efforts of our reviewers. How do journals deal with the unethical practices, the checks and balances in peer review system. We'll then move on to the open science and open access, which is much talked about these days, and also touch base on the threat of cloned journals, which is recently has become a rise in our industry. So what is Springer Nature? Springer Nature is actually have published with most of the Nobel laureates and field medalists. In May 2015, Springer and Nature and Macmillan Education merged together to become one company, which is Springer Nature, and under this umbrella we have various brands: Nature Research, Biomed Central, Springer, Scientific American, Nature Journals on Springer, and obviously Palgrave Macmillan. So where are we based? We are a large company and with offices in 50 locations and more than 10,000 employees working for you. So any idea why all the Nobel laureates and field medalists put their best efforts and faith in publishing with Springer? It is because they follow a foolproof idea of while putting their submission, they follow a foolproof way to make sure that the journal they are publishing into is a good journal and from a reputed publisher like Springer Nature. For that, tips to select a good journal. Whenever you are ready with the submission, please make sure that you are targeting a journal from a reputed publisher like Springer Nature. Please have a look into the editorial board and do you recognize any of the eminent academicians from your area on the board of this journal? Also, see if the journal is indexed in the databases where most of the researchers in your field used to look in for help, like WOS, Web of Science, Scopus, and also Directory of Open Access Journals. Then it is likely to be a good journal. And the authors. Have a look at the list of authors. Do you recognize any of them? Do you see your peers also publishing into this journal? Last but not the least, it is also very important to look into the downloads or the usage of the journal, which shows how much connect the journal has been able to make with the community or the research world. Now we move on to the very important section of this presentation, which is what to look for in a journal. So how to look for a journal which is good, which is validated, and which gives you a platform to disseminate your research and increase the reach of your research work. For that, it is very important that as an author, you always go to the journal website and wherein you will find various tabs. Most important is the submission guidelines. So whenever you are visiting a journal website, especially a Springer website, this is a screenshot taken from a Springer website, so you have the submission guidelines or instructions for authors there, and then you have submit manuscript tab. So the best way to reach to the inbox of chief editor is to submit online. Every article should be submitted online and not through various other ways by, kind of sending your article in email to the EIC or other contact persons with the publisher. Next is the abstracting and indexing information, very important. You find this information at the bottom of every journal page with Springer website, and it shows the various abstracting and indexing databases where the journal is indexed in. Next is the other metrics of the journal. It depends upon how you want your journal and in which, how you want your articles to be published and in which journal. So you will have the impact factor of the journal mentioned here, then submission to first decision, which shows the turnaround time and how much time the journal will take to respond back to your paper. Also have the downloads, which I have already discussed. So downloads is somewhat underrated metric of a journal, but I feel as a publisher it is very important because it shows the number of times a paper is being downloaded and what connect it has with the community. The next section will focus on important points that you should know as an author, just to make sure that you do not miss any point and you don't get rejected or your manuscript is not sent back because you did not follow these important points. So the fastest way to make your article reach the inbox of the editor-in-chief is to make sure that you have read the instruction for authors and followed the manuscript submission guidelines. It is also very important to be sure who is the author, and if you have a number of authors in your manuscript, then the sequence should be correct. The co-authorship and the corresponding authorship should be well defined. In some of the journals, we also have contributions of quantum of each author, which defines the role of the author in authorship. Please make sure that this is the time when you enter all these details into the system, and it is absolutely a big no-no from the publishers and from the journal's end to add, delete, or change of sequence of any of the authors. Now, what is the role of corresponding author? Corresponding author is the main contact point between the journal editors and the authors. So it is a very important role, and it should be dealt with responsibility and should be given to someone who is actually had a maximum quantum of work into the manuscript. Now this, I'll just skip this slide because it is just what I have just described you. It is the replication of that only. Now, what is a copyright form and why do publishers need it? It is because if you do not transfer the copyright transfer form to the journal or the publisher, we possibly cannot disseminate or publish your work. It is as simple as that. Nowadays, people are even going ahead for license to publish. So in this kind of copyright, I think in our journal in JPAC, we have license to publish, which is a very good initiative for the authors. So the authors retain the copyright of their work and they do not seek to get permission from the publisher or the journal to reuse their work. And then we have open access publishing where we have various CC BY, NC, CC BY, NCND type of licenses, and you will get to know about it once you decide to publish in open access mode.
Madam, you have to finish quickly. 1 minute left.
Only 1 minute? Okay. So we'll quickly move on to the peer review process. So is this the feeling that you get when you publish, when you submit your work to a journal, that everybody out there is there to thrash the work of your labor? No. Peer review is a process for improving the quality of your scientific content and to provide better research and better content to the scientific community. There are various types of peer reviews, and I will skip this because of the paucity of time. Then we have cascading peer review in case your manuscript is rejected. Don't worry, it happens to everyone. You're fighting in a very competitive environment with a very limited space, so chill, relax, resubmit, and hopefully you will be successful again. In case you get to submit in a journal which is out of scope of your subject area, what happens? Then we have a very wonderful Springer transfer desk, and the transfer desk helps you with finding the right journal for your research. We have various ways at Springer Nature to recognize our reviewers, and we always keep on trying to motivate the reviewers to support the research community and the journals that we have. So these are the various ways by which we recognize the reviewers and their hard work. How do journals deal with the unethical practices? Now, some of the unethical practices that we have are plagiarism, duplicate submissions. If then there are compromised peer review also, conflict of interest, source of funding, and everything. So for everything, we have committee of publication ethics. We follow their guidelines, and we have our internal research integrity team to deal with any unethical cases and concerns that come up. I'm going to just skip all this because I think we have know-how of what plagiarism is. Now, in order to identify plagiarism, we have similarity report. But remember, similarity report percentage does not define how much overlap is coming into your article. So when we have a similarity report or an authenticate report, we tell our expert editors to analyze the report and not go by deciding over the percentage which is coming in. Now is this duplicate submission, it is, author submitting the same manuscript to 2 different journals at the same time. It is very frustrating because you may end up publishing twice. And the article which is published later is generally retracted in this case, which doesn't look good. Then we have falsification, fabrication, all of this is dealt with the research integrity team that we have. Authorship change request is never ever approved after acceptance. Then we have benefits of OA. OA is the open access publishing. Obviously, we all know if the article is openly and freely accessible to all, it is visible, it is more citable, and it has a better reach. We have transformative agreement publishing, which is a way by which we support those authors who do not have the funds and grants to publish in open access model. We can discuss it more when we have more time. This is and here it is, the best thing. So if you are an author and you don't have open access and you want to spread the word about your research work, or you want to be the marketeer of your research work, what do? Your article is published in a journal. Go to your article, go to the extreme end of your article and you find a link. Copy that link and share it with your peers. That is the link which gives you the right of sharing your research ethically, and it increases the reach of your research. Now there are clone journals also available, so when you are coming to submit to a journal, please make sure that you do all your checks and you don't fall into the trap of predatory publishing or clone journals. So very quickly, I have tried to end this.
Yes.
Yes.
Thank you.
But if you have any questions, please connect with me offline.
Give a round of applause to Ms. Sonal Chaudhary. Sonal has given very good, detail about the process to write article, how to go about. Lot of researchers are present today here. In the morning also, a lot of innovative items have been presented. But to publish, there is a process which should know, and she has explained everything very nicely. We are writing article, but how to reach out. Springer is a journal worldwide. Everywhere it is reaching to all universities. So she has come all the way. We are thankful to you, ma'am.
Thank you very much.
So give a round of applause for ma'am.
Yes. One last announcement. Please submit your research with Journal of Packaging, Research and Technology. I'm also a proud publishing editor for that journal. Thank you.
Wonderful, wonderful. Now we have a next speaker. He is Dr. Narendra Raju. He will be presenting on smart food technologies. He is a senior scientist of food sciences and technology, NDRI Karnal. Yes, Mr. Moyuk.
Dr. Narendra Raju holds a dairy technology degree from Osmania University and a postgraduate degree in food science and technology from Acharya N.G. Ranga Agricultural University. He earned his PhD in dairy technology from ICAR National Dairy Research Institute in 2009. He began his career at NDRI as a scientist, and now he is working as a senior scientist. His research focuses on packaging dairy products, including developments in edible, biodegradable, active, and intelligent packaging. Sir.
Thank you very much.
Welcome.
At the outset, I thank Professor Tanveer Alam sir for giving this opportunity and showcasing the little work what we have been doing it in the food packaging laboratory of National Dairy Research Institute, which is located very close to Delhi, about 125 kilometers from this place. I'm glad that quickly I'll be rushing towards what exactly are the major functions of food packaging. Everyone knows there are a number of functions, but when it comes to the extension of the protection as well as communication functions of food packaging, then this is the place where the smart packaging is being talked a lot, that it communicates to the stakeholders in the supply chain. So no need to discuss much about the market status. It's booming. That's the single line for this particular slide. And I just need to tell that what is the need for smart packaging, because consumers are now more and more wanting to have a non-destructive, on the spot and real-time quality evaluation. So because of this, the need for freshness indicators, the need for smart packaging is growing, is what I wish to say. And the quality of the packaged products, especially the food which is being consumed, is the need of the hour to look at. So there are so many types of intelligent packaging systems. In this conference, you might have got exposure to all of them. So simply, I'll be focusing the gas sensors as well as the freshness indicators that we have been working on. So just to illustrate, those who are maybe new or just exploring, any food product which is packaged with any primary package, we can have some labels on the package which are exposed to the external world, or which, some of the labels which are inside the package which are actually interacting with the internal headspace of the package. So either the indirect smart labels or the smart labels which are directly exposed to the internal package system will lead us to the time temperature indicators which are exposed outside, while freshness indicators which are exposed to the inside of the package. So freshness indicators are not only meant for the fresh food packages, but also to the processed foods. And these processed foods are targeting the quality markers like the ammonia gas or the carbon dioxide gas, the ethylene, ethyl alcohol, and so on and so forth. So as I just said, in a crux, if I want to tell, these three are the major things which are causing some dent in the smart food packaging systems: the TTIs, freshness indicators, and leak indicators. So time temperature indicators, as you are aware, maybe some of you, they are primarily containing three different components. There is a label which gets exposed to temperature, and there is a color change. And this color change in the indicator is irreversible because it has to stay for long to get noticed by the stakeholders in the supply chain that there is a change in the color of the indicator. So that indicates that the product or the package has been thermally abused. So what are the ideal requirements of a TTI? It should be flexible with regard to temperature ranges, because a single TTI for frozen foods, for autoclavable foods cannot be having. So an ideal one should have both of this. It should be small and easily integrated. It should not exceed the package surface area itself. Non-toxic, because many of them are supposed to be applied with food and pharma, and ultimately it should be cost effective. So we can have three different classifications of time temperature indicators: the physical, chemical, and biological ones. In the physical time temperature indicators, it is primarily the physical kind of what we call the trigger mechanisms that takes place, wherein some dye will diffuse from one end to the other end, and the rate of diffusion or the rate of travel of this particular dye will depend on temperature. As and when the temperature rises, the speed of the dye moves faster. While chemical time temperature indicators are primarily based on the chemical reactions that are taking place within the indicator, and there are so many principles, and some of the new or patented technologies are now available in the literature which focuses on the chemical reactions. Ultimately, they are also leading to some chemical change, and they are accelerated as and when the temperature indicators, they focus on the primary indicators like the enzymes or the microorganisms which have been used, and the color change is the same mechanism, but here they are caused due to the biological materials which are present in the indicator, and they are live, and many of the times they actually interact with the internal package, and then they simulate the microbial spoilage of the package. So the time temperature indicator applications could be in frozen foods, meat products, seafood, dairy products, and also in pharma applications. But one of the key things that is to be remembered for developing any time temperature indicator is that the deteriorative reaction that we are targeting and the activation energy of the time temperature indicator should not be falling outside roughly around 25 kilojoules, which is the requirement as per the standard, the reports. Now, let me give you quickly one of the case study application in dairy industry. All the dairy products, majority of them, if not the milk powders, they have to be stored under refrigerated conditions, if not at room temperatures which are just less than 20 degrees centigrade. If they are exposed to different temperatures, the rate of chemical reactions and microbial reactions takes place at a greater degree, and then leading to the spoilage of the product. So in such case, I'm showing you one example of a microbial time temperature indicator that was developed in my lab for paneer. So for this, we started with isolating some of the microorganisms which actually caused the spoilage of the product. And then some of the isolates have been studied very well, and then they have been selected to develop a time temperature indicator. So these isolates were containing Enterococcus species or the Atlantibacter species, Bacillus cereus, as well as Enterococcus faecium. So out of the 4, we started looking at 2 different isolates and try to formulate a smart ink component and diffuse or integrated these 2 bacterial cultures in that and looked at what temperature and at what time the color change of the time temperature indicator can be achieved. So in this prototype, we could see that the color change could be easily noticed, which in terms of the delta E of the indicator. The reason here why we looked at 3 different temperatures is, in the supply chain of dairy products, if the temperature is exceeding about 30 degrees centigrade or above, then we cannot do anything, because if it is less than 20 or 25, we can make some subtle changes in the supply chain and take corrective action. So the developed indicator with these 2 microorganisms could change the color within about 8 to 9 degrees centigrade from the recommended storage temperature. So well before some chemical changes can occur, we can take a corrective action. Now another one is oxygen leak indicator. There are a lot of applications in modified atmosphere packaging. Our Dr. Tanveer Alam himself has worked on modified atmosphere packaging of mozzarella cheese, and here we play with the different gases, and ultimately with dairy products application, we don't want any traces of oxygen gas present inside, because they lead to the rancidity and oxygen mediated reactions. So what we want seal integrity in terms of the package, so that the oxygen cannot permeate from external world, because there is a high vapor pressure outside the package. So this led to clearly looking at the literature to support that oxygen is not at all recommended in any of the modified atmosphere packaged dairy products. So let it be the Indian dairy products or the Western cheeses. Now there are so many popular commercial oxygen indicators, but they are costly, and then many of them need to be imported. Although we have now some of the companies with indigenous know-how in the country to support our industry. We looked at one of the promising principle of electrospinning, so that the gas within the pack can be detected even at low concentrations. And one such example is that this is a patented product, the electrospun oxygen indicator, which we applied it for mozzarella cheese and a couple of others, which can detect 0.4% of oxygen inside the headspace of the package. Now the last segment is freshness indicators. Quickly here, there are 3 prerequisites to formulate or develop any freshness indicator. First of all, we need to look at what are the spoilage markers of a particular product, because each of these product will spoil, and their spoilage mechanisms could be different, and the volatile markers within the package could be different. And we need to formulate a smart ink which can respond to these volatile markers, and we need to support it on a polymer matrix, maybe paper, maybe plastic, maybe by spin coating, etc. So these are the 3 different prerequisites to develop that. So either we can go for GCMS analysis of the product if it is new and no literature is available to look at what are the volatile markers. And one of the first application we could see in the literature is that the applications with the fish. And today if you see the publications, there are large number of publications which are focusing on fish, meat, and of course on fruits and vegetables, but limited with dairy products. Now one of the commercial one, which the New Zealand researchers have commercialized it, the ripe sense for mango. And in Indian context, there are large number of region-specific dairy products which are causing spoilages in different manners. So we looked at one of the primary product, that is Kova, and very important Eastern Indian product, Sandesh, which brings happiness and also some good news to people.
Sir,
these 2
products, 1 minute time.
Yes, sir. These 2 products are packaged with the freshness indicators which have been exclusively fabricated, and this technology is now available with us. Not only single volatile marker indicators, but also multiple now, not only just dual. So the advancements in terms of freshness indicators is that even University of California and Tetra Pak as a company, they started looking at the 3D printed freshness indicators especially for the closures. So to conclude, I wish to say that the smart food packaging concepts or the tools and techniques can evolve in monitoring the real-time quality and freshness of the product. They can even reduce the wastage of the products because we can take timely decision, which helps in timely decision-making process. And also at the end, one of the 5 S's of this conference, the sustainable options for the industry. Thank you very much.
Thank you, sir. Thank you. Wonderful session. And Dr. Raju has given a lot of insights this on smart packaging. Nowadays, all of things we are being a customers, clients looking for the latest use of the application of the technology in the packaging. And he has given nicely all these applications which are in the frozen foods, meats, poultry products and fresh fruits. This is an indicator which is, if it is coming in the market, all the customers will be benefited. And technologies which he has seen is a very simple technology which is already being used by the different European countries and the developed countries. And once if we start getting in the commercial application in India, it will be great benefit to the customers. With a wonderful session, give a big round of applause to Dr. Raju. Thank you, sir. Now, should we go for the question answering 1 or 2? No. So, we'll be closing this session and I'll hand over the microphone to the speakers. Now, before that, what I'm saying that IIP is organizing many seminars. Of course, ISPI is international seminar like this. Very rare we get the opportunity to organize. I'm really delighted to be here. Thankful to Dr. Alam and total group of the people in IIP administration for organizing such thing. And I am really amazed to see the audience and the speakers. Wonderful forum here. Thank you very much. Give a big round of applause for all the speakers and audience and organizer. Thank you.
Thank you so much, sir. May I please request honorable chairs to felicitate our speakers, starting with Dr. Preetam Sarkar, Associate Professor, NIT Rourkela, please. Ms. Sonal Chaudhary. Let's have a good round of applause, everybody. And Dr. Narendra Raju, Senior Scientist, NDRI Karnal, sir. Thank you so much, sir. I request Shri R.K. Mishra, sir, to please felicitate our honorable chairs and co-chairs, please. Dr. Madhav Chakraborty. And Mr. Mayur Katiyar. I humbly request all the speakers to please join us for a group photograph. Request you, sir, to please join us on the stage. Thank you so much, everybody. Now we are starting with the oral presentation session. We are starting with the oral presentations. May I request Samiksha Bisht, Prachi Jain, Ramkumar Deshmukh, Tejaswini, Dhanaji Patil, and Deepika Gupta and Navya Puri to please come forward. Come in the front, please. And we are starting with Samiksha Bisht. You may please come on stage.
Give us a minute, we complete this and then we... Dr. Tanvi, we just complete this and we are there. 2 minutes. Okay, the one which we are evaluating and... I'm sending them, just give one.
इससे करके देखो एक बार, इससे चलेगा ना, इससे हो जाएगा ना, वहाँ नहीं, हाँ हो रहा है, ठीक है.
Yes, Samiksha. Your time now starts. Please.
A very warm good morning to one and all present here. I am Samiksha Bisht and I am pursuing my PhD under the supervision of Professor Kirtiraj K. Gakwad. And today's oral presentation topic is printable edible ink based on waste hibiscus flower and guar gum for food safety and sustainable packaging. The table of content are as follows. And the first one, the introduction. As we all know, edible ink is a ink that we are able to consume, and we are basically focusing on the global concern which is related to the floral waste and the printing ink. Because in temples and the rivers, the floral waste which is generated is more than 8 million metric ton in rivers per year. And in the case of printing ink, we are using different kinds of carcinogenic adhesives and the colorants which are somehow transferring to our food products through the porous nature of the food products, and we are imbibing it and it ultimately causing health effects to us. So based on this, the problem statement that we are focusing is the floral waste which are generated in the temples and the rivers, along with the synthetic ink which is available in the market and the synthetic colorants which are used for its development. So based on this, the proposed solution of my research study is based on the utilization of hibiscus flower for the development of edible ink, which not only promotes the sustainability but it replaces the chemical ink with naturally sourced ink, and we are focusing on the direct printing of the labels through this edible ink. Based on this, the aim and objective of my research work is to develop hibiscus-based edible ink from hibiscus, citric acid and the guar gum, in which the major objective are as follows: to utilize hibiscus as a coloring pigment for edible ink development, to develop the edible ink from natural component, and to study the application over different food products. In which I have followed the methodology which is based on the stirring technology. I have used a temperature of 40 degrees Celsius, and with the help of the screen printing technology, I have printed the ink over the food products. Based on this, the result that has been generated is that with the increase in the citric acid concentration, we have found the rise in the solid content. Along with this, there is a rise in the color property which is related to the development of the flavillum cation. Second one is the rub resistance, and this rub resistance is related to the during the transportation. After rubbing, we have found that our ink was still there and was able to provide the information that we want from our ink. Thus, we can use our ink for the printing technology. And we are talking about the edible ink, so we must focus on the nutritional characteristics. So we have found that with the increase in this citric acid concentration, the antioxidant activity was found to be increased from the 43% to the 62%, which usually emphasizes its nutritional characteristic and antioxidant activity. Based on the rheological property, which is the main characteristics of the printing ink, we have found that our ink has the shear thinning behavior because With the increase in the shear rate, we have found our viscosity to be decreased, and it signifies that the print was smooth while printing the ink. With this, after getting the benefits of the results, we have printed our ink over the paper and different kinds of food products, and we have found that our ink is able to provide the information and the vibrant colorancy which is able to replace the synthetically chemical inks and the printed labels which are available in the market. Based on the conclusion, we are not only focusing on the sustainability by focusing on reducing waste, but also providing an naturally sourced ink which is high in antioxidant activity. Thus, we are providing an ideal solution for the food printing industry. Thank you.
Thank you. Great. Within time you have finished?
Yes, sir.
Okay. Just you tell me one question.
Yes,
Okay, how commercially this ink is viable? Did you compare, have you done any comparative study of market and as well as your ink? Just
I have, for the commercial point of view, I am just focusing on, I have printed my ink. No. Okay. For the commercial point of view, I have printed my ink over the apples, and I have found that after rubbing also, the print was still there. And when I am storing this ink for 2 to 3 months, its shelf life is not degraded and the print was still there.
Okay, thank you.
Thank you.
Thank you. Great. Okay, thank you. Samiksha, now we have another participant, Prachi Jain. Miss Prachi Jain.
So shall I start?
Yes, your time starts.
Good afternoon, everyone. I am Prachi Jain. I am a PhD scholar at IIT Roorkee. So before talking about my research, I would like to give an overview of the problem statement we are addressing here. So basically, right now the food industry is relying on iron-based oxygen scavengers, which usually looks like this. However, iron-based oxygen scavengers are a problem because they are metallic in nature. Oxygen in food packages is a huge problem because it can spoil your food in many ways. For example, rancidity, microbial spoilage, oxidative degradation, and browning. So in order to tackle all these problems, we are using iron-based oxygen scavengers. However, they have several disadvantages. For example, metal contamination, setting of inline metal detectors, accidental consumption could be harmful to human health. They are not compatible with microwavable products, quick saturation, and non-biodegradability. So in order to address all these issues, research in the past have been accelerating towards finding a potential solution, and many researchers have tried utilizing unsaturated hydrocarbons, ascorbic acid, enzymes, and even microorganisms as oxygen scavengers. But due to one or more limitation, their actual application is restricted. So we have come up with a potential solution, which is a plant-based alternative. What we are using is plant material to replace iron-based oxygen scavengers. The plant material which we are using is acacia catechu powder, which is also known as katha in India. Katha is something which we are consuming from a long time because katha is the brownish paste we are using in pan materials. And then we are combining it with sodium carbonate. The idea behind using sodium carbonate is to make the system moisture dependent. That is, this particular system only activates when the sachet is put inside the food package. It is going to draw moisture from the food product. It is going to form sodium hydroxide, which is then going to provide alkaline conditions for catechu powder to scavenge oxygen. This innovation is 100% food grade, sustainable, plant-based, as well as an economic alternative to what we are using right now. So this was my experimental setup. I have tried using acacia catechu powder in combination with sodium carbonate. The main ingredient in the catechu powder is catechin, which is scavenging oxygen. And 1 gram of catechu powder contains around 74 milligrams of catechin. So we have experimented in this way, and oxygen was measured every day. So in order to understand the real-time applicability, we have utilized 3 different temperatures pertaining to food storage temperatures. For example, 5 to 7 degrees Celsius for refrigeration temperature, 25 degrees Celsius for room temperature and higher temperature. Then we have also tested the particular product at 3 humidity conditions to understand its applicability towards different moisture food products. For example, 75% RH, 55% RH and high moisture food product 95% RH. This is how it scavenges oxygen. Basically, catechin undergoes series of oxidation reactions, and in these reactions, the oxygen is consumed. Since catechin quinones are being formed, there is a browning of the composition, which may also act as a indicator to consumers that their product is the product is safe and the oxygen is consumed inside the package. This is all the this much time it took for oxygen to reach zero at different temperatures as well as at different humidity conditions. We were able to achieve 0% oxygen levels. These are the graphs which shows plots of oxygen scavenging capacity versus time for all the samples. We have tried using different formulations. For example, catechol powder and sodium carbonate were used in different ratios. Through our experimentation, we found that the best composition was when they were used in equal amounts. Now we have calculated oxygen scavenging capacity as well as rate to compare it with commercial oxygen scavengers, and we got the total scavenging capacity of this particular composition is 15.7 cubic centimeter per gram for 1 gram of composition, which is comparable to iron-based oxygen scavengers. We have also done thermal stability test as well as FTIR to understand its chemical changes which are happening during the chemical reaction, as well as to understand what will be the thermal stability for the temperatures that are involved in food processing. I have also done some material characterization tests, for example, surface area, particle size, as well as some SEM micrography. This is how we plan to find an alternative solution for iron-based oxygen scavengers. These are the awards which I have received on this. Thank you. And in the last, I just want to say that sustainability is a long road, and the least we can do is take one step at a time. Thank you. Thank you, sir.
And she has completed her talk within 5 minutes. Good. Now the jury can ask.
Yes, sir. Right now we have developed sachet forms, and now we will be working on oxygen scavenging films. We can try it in multi-layer packaging. Ma'am, that one is pyrogalol, which is a chemical form. This one is based naturally, wholly on plant product. Ma'am, pyrogalol is chemically available in pure form. This is a plant product. Ma'am, I have just started 3rd year of my PhD in January.
Okay.
Thank you.
Okay, thank you. Great. Now we have a next participant, Ram Kumar Deshmukh.
Good afternoon to all of you. My name is Ram Kumar Deshmukh. I am a PhD scholar at IIT Roorkee under the guidance of Professor Kirtiraj Gaikwad. So I am here to present my work, a little contribution towards the sustainable packaging. So my topic is a green composite by incorporating with agro-waste microfibrillated cellulose for heat soluble packaging applications. Here I will give you an overview that we have synthesized plant-based microfibrillated cellulose and incorporated into the biopolymer to make heat soluble packaging. So all of us, since the last 2 days, we have a lot of listening about different challenges through synthetic plastic. So now what is our problem? To find alternative solution for these plastics. So we have made a little effort. So there are a lot of data on the plastic production, plastic pollution, and their harmful effect on the environment, air pollution, water pollution, and soil pollution. Even on the news, now you have read the microplastics entered into the human blood and breast milk also. So we can assume how much this is going to affect adversely to the human health. So what is the solution approach? The solution approach is to, if we cannot completely minimize the food wastage, we can divert their wastage or valorization of those waste into the value-added product. So our approach is to extract bioactive compounds and bio-based material and incorporate those material into the polymer matrix, so we can use those waste product into the different packaging application. In my research, what I have done, we have synthesized microfilament cellulose from lychee cell, and then MFC, that is microfilament cellulose, incorporated into the guar gum and PVA polymer matrix, and we made a heat sealable packaging application that can be used in the different food product packaging application. So this is my product, which is thin film, and we have tried to packed different food product, food commodity. So this is my product, and there are some data related to my research that you can see that thickness was not much affected through the incorporation of MFC, and water solubility reduced a little because of the incorporation of microfilament cellulose, which is good, because if we are going to utilize those packaging material into the food product, it may be some cases that it will contact in the aquatic condition, but there are a lot of challenges because it is still very sustainable to the moisture, because those biopolymers are very hydrophilic in nature, so we are in processing to make it aquatic stable in further work. And we have found that after incorporating the fibers into the composite, their mechanical property improved significantly. As you can see, their elongation also improved significantly in our research work. The sealing strength, what we found that unique property due to the incorporation of PVA into the composite matrix, which was not found in the guar gum neat composite, which was very convenient when we talk about the packaging application, because if your product has been not sealed packaging, it is very hard to pack something into your product. So the sealing strength was found significantly improved after incorporating our MFC. The barrier property, that is the water vapor barrier property, also significantly decreased after the incorporation of different percentage of microfilament cellulose in our composite. There is some microscopic observation. We found that the guar gum and PVA that need film has a smooth surface when it was knit, but added with microfilament cellulose, it found some agglomeration due to their fibers. And last, and I would like acknowledge the Prime Minister Research Fellowship to fund my research, and IIT Roorkee and FFPL to provide me the facility for carrying out my research work. And last, with my personal message, I would like to tell finding sustainable material is not ultimate solution until we incorporate sustainable behavior in individual. So thank you very much for giving me the opportunity.
Okay, thank you. Jury members, any question?
Yes, sir. Yes, sir. Sealing strength you're talking about. Sir, after incorporating microfluidics, the sealing strength found, even after you will pull that, you have to make it very force. You have to put very force. So that was exceptional sealing strength, I can say that. I don't have now, but I can, if I'll in future, maybe the commercialization will be, we are looking also for commercialization, because at a lab level, it is very tedious task to scale up and make it automatic, but if we will get support from the commercial industry, so we can make it into the market also.
Have you done any quantitative testing on sealing strength?
Yes, sir, we have done sealing strength. So we found that the sealing strength of our 7.4 megapascal with the extensive increase in the sealing strength after incorporation of that our MFC into the packaging material, which was for PVA. It has a very high mechanical property, but that also compromised with the barrier property, so which was increasing when we are incorporated MFC. So that we cannot compromise the barrier property for mechanical strength. So that.
Okay, thank you. Okay, thank you. Thank you.
Thank you so much.
Now next is Tejaswini D. Patil. Okay, your time starts now.
Yes, sir. A very good afternoon to all. I am Patil Tejaswini Tenaji, PhD Research Scholar in the Department of Paper Technology, IIT Roorkee, under the supervision of Professor Kirtiraj K. Gaikwad. And today I will be presenting my research work on the design and development of novel edible straws based on barnyard millet for beverage industries, which is a sustainable alternative for paper and plastic straws. So in this presentation, first I will discuss why do we need edible straws over paper, plastic, PLA and other biodegradable and edible straws available in the market. Then what is the problem statement, then proposed solution, the methodology we used, various specifications of edible straw, then various properties of straw and how our straw is unique in market. So why do we need edible straws? As we all know that various polymers such as polyethylene, polypropylene, polyvinyl chloride, like polymers are most commonly used in the development of single-use plastic straws, but now government has banned the single-use plastic straws as these straws and stirrers account for 7% of total plastic pollution, plastic waste, and 4% of these plastic straws end up in the ocean and causes environmental challenges. Also, in market, like Starbucks and McDonald's have, so again, you all have must heard of the PFAS chemical, which is a class of chemically and thermally stable compounds, which are very harmful to our health. And unfortunately, many of the paper straws available in the market contain PFAS-like chemicals, and ultimately these paper straws end up sent to landfills where PFAS do not degrade and but migrate into environment. Although these paper straws are suitable, although these paper straws are alternative for plastic straws, but their mechanical properties are still very limited, and again the hydrophilic properties of these paper straws is the another main concern. So okay, accordingly a kind of healthy, hydrostable, then PFAS free, allergen free, but then decomposable and edible straw with excellent mechanical and heat resistant properties are urgently needed. So we have worked hard to bring the solution over this problem, and we have developed the barnyard millet based edible straws as a sustainable alternative for paper and plastic based straws. So this is the methodology we have used, where barnyard millet flour along with other ingredient is mixed well, then and shaped after many processings, shaped into a straw, and these straws are without any chemical preservatives and synthetic adhesives. The straw can be eaten along with the food material or beverage we are consuming, or after the consumption of beverage. So these are the specifications of barnyard millet based edible straws. The straw weighs 5 gram and it has a thickness of 1 mm approximately. The straw can sustain in the temperature of 0 degrees Celsius for 4 hours, 25 degrees Celsius for 2 hours, and at 85 degrees Celsius for at least 5 minutes. and it has the shelf life of 90 days minimum.
Yes, you have 30 seconds.
Yes,
Please
sir.
conclude.
So this straw is very, like from these results we can, I can conclude that the straw has a strong water resistance properties in green tea, orange juice, milk, tea and Coca-Cola. These are the thermal properties, and the straw has also the better heat resistant properties, better mechanical properties, and these straws are extra healthy, extra strong and durable, suitable for hot drinks. Then it has a lower glycemic index as compared to the other edible straws available in the market, such as rice and wheat. They are maida free and all types of allergens, and they are the best for vegans. These are, thank you so much. Sir, at lab scale, we have like 1.92 rupees per straw. Almost 2 rupees, ma'am. But it is again lower than the other edible straws available in the market made up of rice and wheat. They are 8 rupees per straw. Like there are some brands. Yes.
Okay. And during my last interaction,
Yes, sir.
and after test, I
Yes,
told
sir.
you
Actually,
what the improvement you have done
Sir,
so far.
actually, the sample I gave you that contain some green. Yes. No, sir, not stale, but something like citric acid actually was there. So, shelf life, ma'am, now it has minimum 90 days of shelf life, like 3 months. But again, the straw is still, and we are, studies continue, ma'am. So again, I can say more than 3 months. Sir, not, it is edible, sir.
Are you giving any coating, hydrophobic?
Sir, actually now the properties of these straws are even better than other straws. I have tasted like 4 to 5 straws I bought from market, and I tasted. Mine straw is can sustain higher temperature for longer time, even lower temperature beverages for longer time. Yeah. 20 to 30 minutes, ma'am, it will sustain that temperature, ma'am. Okay, thank you, sir. Thank you, ma'am, everyone.
Now we have Deepika Gupta from IT Mandi.
Yes.
Yeah, good.
So shall I start? So good afternoon, everyone. Myself, Deepika Gupta. I'm an inspired scholar in the School of Chemical Sciences at IIT Mandi. So today I'm here to present my research work on Himalayan abundant Tegitis minuta chenchaloil embedded self-crosslink chitosan films for active food packaging. So this is the introduction of my work. You know that with the growing population, the demand of food is steadily increased. But according to the recent data, 1.3 billion tons food is wasted before it is consumed. So food security is also important. So here, the food packaging plays a crucial role in preserving the food quality and also extend the shelf life of food. So many traditional-based packaging materials such as plastic-based material contribute to environment pollution, and it's also provide the insufficient protection from harmful UV light, oxidation, and contamination from the microorganisms that present in the environment. So there is a need for development of biodegradable active food packaging material. So we can develop biodegradable active food packaging material by incorporating the active substance such as natural extract, nanoparticles, enzymes, agrovics, etc. So now, question is arise that, why do we need antioxidant packaging? So high-fat content food react with oxygen and get oxidized. This leads to rancidity of flavors and reduce the shelf life of food. So here, you can see that on the left-hand side of the packet, the food get oxidized due to the oxygen exposure, light exposure, moisture loss or gain, and this leads to be the loss on the crispiness, texture, and rancidity, and it's also reduces the shelf life of food. But on the other hand side, on the right hand side, the food, high-fat food such as wafers, walnut, almonds packed in the antioxidant packaging, and it slow down the oxygen rate and maintain the texture, taste, quality of the food. So this is the overview of my work. I'm living in the Himalayan region. So we intended to utilize Himalayan abundant sources as an active source. So here we utilize Tegitis minuta
which is wild marigold, yeah, like jungli gende ka phool, and we extracted the Tagetes essential oil from this Tagetes minuta, and we done the GCMS and NMR for this essential oil, and we found that there is some Tageton, a dihydrotegeton compound which leads to be higher antioxidant, and we used for the high fat content food, and then we checked the biodegradability of the film. This is the film fabrication method of the film. So here we fabricate chitosan and thylated chitosan based film incorporated with Tagetes minuta essential oil. So here the thylated chitosan as a cross-linked by disulfide bond and entangled with chitosan, and which is lead to be formation of SAMI-IPN, which is SAMI interpenetrating network that serve as an incorporation of essential oil. So this is the different composition of the film. CS, that means chitosan film. CS, TCS, that means chitosan and thylated chitosan film, and the different amount of the oil. And here for the higher amount, we have CS, TCS, TMO1 film. Then we check the water barrier properties of the film. So here you can see that for the CS, TCS, TMO film has good water barrier solubility as compared to other films. Then we check the mechanical properties of the film. So here CS, TCS, TMO have good tensile set. However, the elongation at break is decreasing. Then we check the UV barrier properties of the film. At 280 nanometer, it shows the lower transmittance for the CS, TCS, TMO1 film as while maintaining the transparency of the film, you can see here. So then we check the antioxidant activity of the film against DPP radical, that is 2,2-diphenyl-1-picrahydrazine. So here for the CS, TCS, TMO1 film has a 88% antioxidant activity as compared to other films. Then we check the food packaging application on high fat content food. So here we pack the French fries and fried potato wafers, and this is a day one images of the packed image, and then we check the lipid oxidation of the film via TBR assay, and here we found that in the case of French fries and potato chips, the CS, TCS, TMO have lower lipid oxidation as compared to other films. So, and the last, this is the conclusion of my slide. For the CS, TCS, TMO film, we got the reduce in the lipid oxidation and higher in the antioxidant, UV barrier, water barrier, and got the higher tensile strength. And you can see here, okay. Sound please. You can see here the crispiness of the film after crispiness of the chips after 1 month. I think there is a sound problem. And the last, I would like to acknowledge my supervisor, Dr. Garima Agarwal, my lab mate, sir, for the funding, DST Inspire Fellow, DST Inspire for the fellowship, and IIT Mandi for the research facilities, and the last ISPI to give me this platform and this is my beautiful campus. Thank you all.
All essential oil have different fragrance inherent. How do you control that?
Sir, here I'm using very lower amount of the oil, and so we can control by using lower amount of the essential oil. This packet, not on we have done on the lab scale. Then we found that the cost of that packet 100 rupees per meter square. And the thing is, ma'am, the second day of my PhD journey, and I found that I'm roaming around my campus. Then I found that एक आंटी थी, उन्होंने मुझे बोला कि ये कुछ काम का नहीं है, ये वेस्ट है, वो जला रहे हैं उनको, क्योंकि उनको वहाँ पे क्रॉप करना है, फिल्ड करना है. तो मैंने उसको उठाया, मैंने बोला कि लेट्स डू इट समथिंग, एंड देन आई गिव इट टू IHBT पालमपुर. देन दे एक्सट्रैक्टेड द ऑयल. देन मैंने उसको अपना लैब स्केल पे उसको कंट्रीब्यूट किया कि दिस इज वेरी बिग थिंग फॉर मी. From oil for that purpose? No, we can use direct as a powder form, we can use that. But in the case of oil, we in the case of oil, you need to use lower amount of the, as compared to active powder or as well as other things. Yeah.
So Deepika, one question.
Yes, sir.
You used essential oil.
Yes, sir.
Essential oil itself is highly volatile.
Yeah,
For example, if I put essential oil here, after 2 days it will get vanished. So how you are going to make sure that this is acting as this one?
Here using.
And one more question.
Yeah.
Because what was the oxygen percentage at the end of 1 month in the package?
Okay. Your first question is, here I'm making a SAMI interpenetrating network, that is making a trap for the incorporation of the oil. So this leads to be very slow rate of the releasing of the oil. That is like I am making a semi-IPN. So basically that serves as this is a different thing in my work that compared to my like other research work. I'm not saying the work is not good, but this is a different thing in my work. And the second like answer, I haven't checked the oxygen. Like I'm the only one in my institute that doing work.
That is the important, because
Yeah, I know
oxygen
that.
concentration,
I'm going to
if you don't know, you are, I mean, you cannot say like, okay, this is because of oxidation or something else. And itself, any oil is highly oxidized oil. Like for example, whatever the product you are looking for, that it itself can get oxidized.
Yeah.
So that is the reason why, I mean, this is question I'm asking.
I want to just add on your project. There should be the order test. You have to order pickup test you have to perform, because the essential oil, it has inherent fragrance and flavor properties. Another is that you have to also mention the safety part, migration and leachability.
Oh, yeah,
In
yeah,
future
yeah.
you can add.
Yeah, yeah, yeah,
Thank
sorry.
you very much.
Yeah.
Thank you very much. Please. Navya Puri. Miss Navya Puri, please. Your time starts now.
A very good afternoon to everybody present over here. Myself, Navya Puri. I'm an MSc student at IIP Delhi. I have attempted to create a study on analyzing the physical and chemical attributes of bioplastic and PET-based bottles for packaging drinking water. So we all know that plastic is harmful for our environment. Still, we are keeping it in our hand. So what alternatives do we have? Everybody is producing new biodegradable materials, but what about the compatibility commercially and replacing the existing materials? So today, the global concern over plastic waste has led to the search of eco-friendly materials. The research shows that if the current rate continues, then by 2050, there will be production of 1,200 crore tons of plastic waste. So we need an alternatives that can be replaced to the PET bottles in the market. The basic process through which the bioplastics are developed is extraction of raw material from plant agricultural feedstock, processing into the intermediate and final products, the organic waste collection, finally decomposing into the soil and entering back into the system. So what I did, so moving further, I found a gap between that there is immense research going upon that what new materials can be incorporated or brought up commercially, but there is I found that there is lack of research that how we can compare the properties of the two materials that we are producing further. So I have performed 8 quality tests upon 2 samples. One was the existing PET bottle and another was a bioplastic based bottle that I got arranged. So first, the overall migration test. The test indicates that what amount of material or any constituent can be transferred from packaging material to our food products. So it was found that the PET bottle shows extremely low migration rates, while bioplastic bottle also showed low rates, but one of the samples showed the color migration, which is not acceptable. So it indicated that there might be some contamination in the material or during the processing. These were some of the pictures taken during the testing. Another was the density. So density affects the strength of the material. So upon checking, as theoretical values say, the PET bottle was around 1.42 of gram per centimeter square, whereas another was 1.2. So it was estimated that the polymer used by them was PLA along with some PHAs and other plasticizers and fillers. The thickness parameters determine the durability of the product. So if we discuss about the thickness, the bioplastic bottle was twice thicker as compared to the PET bottle. This shows that to maintain the equal strength as compared to the PET bottles, double amount of material need to be used by the manufacturers of bioplastic bottle. More raw material, thus more cost. Further, discussing upon the clarity, the transparency among water bottles is utmost important for catching the eyes of the consumers. So both the samples showed equally good transparency rate. The differential scanning calorimetry was performed for the bioplastic bottles. One peak was observed at 70.75 degrees Celsius, which indicated the presence of some PHAs. Apart from that, a high peak was observed at 368.62 degrees Celsius. It was not near the PLA temperatures, but we need to find that what more products and plasticizers might be added which led to this type of graph. Another mechanical test that was performed that is important for judging the analyzing and properties of bottle is drop test. So this shows that the impact strength of bioplastic bottle is quite less than plastic bottles. The brimful capacity and the closure leakage tests were equally good, and there was no leakage was observed. If we discuss about the bioplastic bottle, we can conclude that it reduces it is cradle to cradle approach, and it reduces the carbon emission and creates an eco-friendly alternatives. But there is a limitation. They leave microplastic in the soil, which
Please
again,
conclude within 10 seconds.
Yes, sir. And the cost also needs to be analyzed, and further sources moreover the further sources need to be determined that how the cost can be reduced. For future perspective, the biodegradation test will be performed, and further cost reduction will be taken into account. And further, I feel that bioplastic bottles can create a revolution in the industry. Thank you. Sir, actually the sample that was available to me was in the form of complete bottle, not as a film or polymer. So the machine that was available with me were not in the form of, like it has for films. So I'll work upon that and bring new studies further.
Okay. Thank you, good efforts. Many more study need to be done for
Yes,
this particular safety, migration, leachability, specific migration need to be done.
Yes.
Because you are doing the comparative study for the two different materials, bioplastic and PET. Thank you very much. Thank you very much. Really, it was excellent, what we can say, session. In spite of that, we are waiting, we are short of time, and I'm very happy the way the young researcher presented is so nice, excellent way, full of confidence, and a very good study they have taken. And my best wishes. Thank you very much. Thank you.
So with this, we come up to the end of the research conclave. I request everybody, those who haven't had their lunch yet, may please have their lunch, and then we'll proceed to the main hall for the valedictory session. Thank you. And I would like to inform that the results will be announced in the valedictory itself.